How does twilight invite stillness and reflection? Why does the sky glow with warm colours at sunset? How does the world's rhythm shift as night begins? At twilight, the sky is gently transforming overhead. The first hint of evening coolness brushes your skin as the sun dips low, painting the horizon in swaths of soft orange and pink. High above, the blue dome of day begins to deepen, fading into richer shades. You watch quietly as each passing minute brings a new change of light, a golden glow mellowing to peach, then to a dusky lavender. The world seems to hold its breath at this hour. Even the birds have grown hushed, as if pausing to observe the day's finale with you. Twilight has a way of inviting reflection. In the gentle dimming, you might find thoughts of the day drifting through your mind, only to dissolve into the quiet. It's a natural pause, a time when many cultures pray, reflect, or offer gratitude. With the rush of daylight over, worries and tasks lose their urgency. You can almost feel them slipping away along with the sun's rays. Any tension in your body softens. In this transitional glow, you give yourself permission to simply be. It's a moment of emotional exhale, a quiet release of the day's energy, clearing space for the calm of night. Near the horizon, clouds catch fire with colour. Their edges are lined with brilliant gold where they face the sun, while their tops bloom in warm rose hues. These colours are nature's gentle physics on display. As sunlight travels a longer path through the atmosphere at day's end, the blue tones are scattered away into the expanse of sky, leaving only the warmer reds and oranges to reach your eyes. It's a quiet magic of the air, what scientists call Rayleigh scattering, unfolding in real time. Yet in this calm moment, it simply feels like the sky is offering one last tender show before night. Slowly, the sun's bright disk sinks toward the horizon, glowing a deeper orange as it goes. When it finally meets the distant ground, the orb seems to flatten slightly, a trick of the atmosphere bending its light. In those last moments, the sun's light becomes a gentle red ember. It gilds the edges of clouds and treetops with a final spark. Then, with a subtle flicker, it slips completely out of view, below the far edge of the earth. The bold oranges on the horizon soften into a dimmer apricot, then slip into dusty mauve and gentle grey-blue. Overhead, where once it was pale azure, the sky deepens to a tranquil indigo. You might notice a single star appearing, possibly Venus or another bright planet, gleaming like a tiny beacon just above where the sun vanished. Sometimes, even a delicate crescent moon hangs low in the sky, cradling the last light of day in its silver glow. This is the onset of twilight, a delicate pause between day and night. In this half-light, the world is cast in cobalt and shadow. Colours of the day drain away, leaving a serene, monochrome scene. You find comfort in the gradual fading of light. It feels gentle and unhurried, as if night is politely waiting for you to be ready. Around you, a few more stars now punctuate the darkness, each pinpoint of light growing bolder as the night deepens. Perhaps nearer at hand, a different kind of light winks in and out, the gentle flash of a firefly floating over a meadow. It glows for a heartbeat, then disappears, like a tiny star playing hide and seek above the grass. Another flickers in reply further off, and soon a handful of these living lights are blinking softly in the gloom. They mirror the heavens in their own small way, earthly stars coming out to join the celestial display. As minutes pass, the high sky turns from indigo to a velvety navy blue. Above the western horizon, you may see a faint glow still lingering, a final memory of the sun's farewell. Opposite the sunset, in the east, the sky near the horizon grows darker too, with a diffuse band of deep blue rising upward, the Earth's own shadow slowly creeping across the atmosphere. Just above that darkening band, a subtle pink light sometimes appears, a rosy twilight arch known as the belt of Venus, gently separating the night from the day's last glow. These delicate colours and shadows gradually dissolve as darkness continues to gather. The dome of the sky is quietly transforming into a window onto the cosmos. There is a peaceful inevitability in this transition. The day's warmth and light slip away without fanfare, replaced by the cool mystery of night. Yet nothing in this change feels abrupt. It is as though nature were dimming the lights gradually, ever so softly adjusting from bright to dark. In the fading glow, familiar landscapes turn to silhouette. The distant trees and hills become charcoal cutouts against the dim sky. A calm stillness settles across the land. You take a deep breath, the air now cooler and carrying the subtle scents of evening dew and cooling earth. Around you, a few more stars now punctuate the darkness, each pinpoint of light growing bolder as the night deepens. High above, new stars seem to fade into view with each passing minute, like shy friends finally gathering courage to show themselves. You are witnessing a grand but quiet shift. Our Earth itself turning steadily away from the sun, rolling you into night. On the far side of the planet, beyond your sight, a new day is beginning for others. This shared dance of day and night continues, undisturbed by our presence, an endless, silent ballet of the spheres. For now, you are on the night side of that turning Earth, being welcomed into its gentle darkness. Twilight is ending, and true night is arriving. In this deepening gloom, your senses begin to adjust, ready to embrace the quiet wonders that will unfold after the sun's departure. Somewhere nearby, a lone cricket begins to sing, its rhythmic chirping gently stitching the silence. Night has truly begun. The warmth of day has faded, and now the night air gathers around you like a cool, gentle blanket. With the sun gone, the ground beneath your feet steadily releases its heat into the dark sky. You can feel a slight chill seeping upward from the earth, the start of a nightly cooling that settles everything down. The breeze that danced during the afternoon is barely a whisper now. In some moments, it's completely still, as if the very air is resting. Leaves on the trees barely stir, and the earlier rustling of the world has quieted to a soft hush. Without the sun's energy stirring the atmosphere, the winds become calm and measured. The air near the ground cools faster now, growing dense and heavy as it loses heat. That cooler air gently slips beneath the lingering warmth above, creating a low, horizontal lake of cooler air hugging the earth. In this stable, stratified night air, there is little to make the wind rise or storm. Instead, it glides slowly and peacefully. If you stand very still, you might notice faint movements of air, perhaps a delicate current brushing past your skin, carrying the scent of grass and distant wood smoke. But mostly, the atmosphere is settled and tranquil, as if exhaling after the long day. As the daytime world curls up to rest, the nocturnal world begins its gentle awakening. Birds that sang under the sun have gone silent, tucked into their nests and perches. In their place, night creatures stir softly. You might glimpse a bat flitting overhead, silhouetted for an instant against the last deep blue of twilight. Its wings make no sound that you can hear as it darts after insects in the dusk. In the distance, perhaps a night bird calls once, a soft hoot that punctuates the quiet, and then all is still again. The transition from day to night is not just in light and temperature, but in life itself, as everything adjusts to a slower, softer rhythm. Perhaps at the forest's edge, a deer steps out to graze, its hooves making only the slightest crunch on the grass. It moves carefully under the dim sky, sensing the safety that the quiet night affords. In different landscapes, the night brings its own subtle breezes and calm rhythms. Along the coast, where the land cooled faster than the sea, a tender breeze now drifts from the shore out toward the water, reversing the daytime flow. Over hills and mountains, cool air gathers at the peaks and glides downslope, flowing into valleys like an invisible, slow-moving river. By dawn, those valleys might be filled with pockets of mist or cool fog, a quiet gift of the night's serenity. Every environment has its nocturnal patterns, gentle winds that only the darkness knows. As the temperature drops, you might notice dew beginning to form. The grass underfoot turns damp and cool as water vapor condenses on each blade. A sweet, earthy fragrance rises, the smell of dew and soil and night-blooming flowers beginning to open their petals. In the calm of the evening, these scents linger in the still air. It's a perfume of nighttime that often goes unnoticed in the bustle of day, but now you can savor it. Many blossoms that hid their faces in daylight now come alive in darkness. Evening primroses slowly unfurl yellow petals after dusk, and moonflowers twist open to reveal white, star-like blooms that shine in the gloom. Their fragrances intensify in the cooler air, attracting nocturnal pollinators or simply perfuming the night. Meanwhile, some day-loving flowers close up until dawn, conserving their energy until sunlight returns. The garden has its own quiet rhythm, synchronized with the sun's rise and fall. In this way, plants, like animals, follow the gentle rules of day and night. Overhead, if a cloud drifts by, it appears only as a faint shadow against the starry sky, illuminated subtly by the glow of moon or starlight. Often the night sky is clear, since the ground's cooling can cause any clouds to settle or dissipate. The few clouds that remain hang low and unmoving, no longer driven by daytime winds. In their stillness, they too seem to be resting. The weather of this night is mild and unobtrusive. No thunder, no harsh winds, just the quiet equilibrium that follows sunset. It's as if the atmosphere has decided to take a gentle pause. You can almost feel the sky watching over a sleeping landscape, protecting it with calm, stable air. This is the hush of nocturnal weather, a world where each breeze is deliberate and soft, each chill in the air a reminder that night is a time for rest, for the earth itself. Even the stars seem to appreciate the stillness overhead. On a calm night like this, they hardly twinkle at all. The air is so steady that the starlight comes through almost unflickering, each tiny beacon shining clearly and constantly in the dark sky, like a promise kept without wavering. Breathing in, you feel the cool freshness fill your lungs. The air feels purer and lighter at night, washed clean of the day's heat and dust. As you exhale, you let go of any lingering energy from the day, joining the natural world in its quiet repose. Under the stars, in the embrace of the gentle night air, you sense that everything has slowed down. The Earth's surface is cooling, The winds are whispering lullabies, and the world prepares for a tranquil night's slumber. In the dimness, all familiar shapes have merged with the darkness. The long shadows cast at sundown have faded and disappeared, but they leave behind a quiet story, one that speaks of the sun's journey and the shape of our world. As night settles fully, the memory of those shadows still gently reminds you of the day that was, and of the unseen curves and motions that continue in the dark. In the fading moments of daylight, shadows grow long and soft, speaking in a quiet language of light and darkness. Think back to the late afternoon when the sun hung low. Every tree, every building cast a stretched out shadow across the ground. Those shadows were thin and long, pointing away from the setting sun as if reaching out to the coming night. As the sun sank further, those dark silhouettes lengthened even more, moving imperceptibly but surely. Edges that were once crisp at midday became diffused and gentle at dusk. It's as if the shadows themselves were getting drowsy, blurring and merging with each other until, finally, night erased them altogether. There's a gentle poetry in those late-day shadows. As they stretched across the lawn or the street, many a person has felt a bittersweet calm, watching their own shadow grow tall and thin. It's as if the day, in its final hour, is slowly waving goodbye. Children playing outside know it's time to head home when their shadows become giants. Farmers in fields see the long shadows of trees and understand dusk is at hand. These moments carry a nostalgic tranquility, the kind that makes you pause and breathe a little deeper. The shadows seem to invite reflection, mirroring our elongating thoughts at day's end. In the hush of these minutes, the world feels both fleeting and eternal. The simple sight of darkness lengthening on the ground, touching something timeless within us. All through the day, shadows mark the passage of time. In the morning, a shadow lies long and angled from the east, and by noon it shrinks to a short puddle beneath its object. By evening, it stretches out far to the east. In this way, a simple stick in the ground becomes a quiet clock, its shadow moving like the hand on a dial as the hours pass. Long ago, people built sundials, carving numbers around where a shadow would fall. With each hour, the sun's rays would shift, and the shadow would gently glide to a new position, wordlessly telling the time. You can imagine the slow sweep of a shadow across an ancient stone sundial, silently keeping pace with the turning earth. Even indoors, you may have observed this silent dance of shadows. A sunbeam coming through a window moves across the floor as the afternoon progresses. A chair that was half in light is eventually fully in shadow. Perhaps you noticed how the golden patch of sunlight on a wall shifted and then vanished as twilight came. It's a small daily routine. The house itself, telling time through sun and shadow. When that last sunbeam disappears, the room gently dims, and you intuitively know that day is done. Shadows not only tell time, they hint at direction and even the shape of the world. When you face the sunset, your shadow extends behind you toward the east. At sunrise, the opposite happens. Your morning shadow points westward. As the day goes on, these dark outlines pivot, tracking the sun's journey across the sky from horizon to horizon. Observant travelers could use them as a compass of sorts, knowing that at noon, the shortest shadow points north or south, depending on which half of the world you stand on. In this subtle way, shadows carry information, a secret language for those who listen. Centuries ago, a wise observer of nature learned something profound from shadows. In one city at noon, he noticed a tall column cast no shadow at all, while hundreds of miles away, at that very same moment, another column's shadow stretched clearly on the ground. This could only happen if the surface of the Earth was curved. From such simple, quiet clues, the differing lengths of shadows, the roundness of our planet was revealed. The Earth's curve spoke through those shadows, even if it took human curiosity to hear the message. It's a gentle reminder that even everyday darkness and light hold secrets about the world we live in. When the sun set this evening, it wasn't just the land around you that grew dark. Opposite the sunset, you might recall seeing that dusky band climbing in the eastern sky, Earth's own shadow casting itself into the atmosphere. That broad, curved shadow slowly overtakes the pinkish glow, the belt of Venus, above it, until the last light fades. The curve of that shadow along the horizon is another whisper of Earth's shape, a nightly advertisement of our planet's roundness for anyone who cares to notice. It appears quietly, without announcement, and dissolves just as quietly into the oncoming night. Yet even with the sun gone, another light can sometimes cast shadows in the night. If the moon is up and bright, it takes on the sun's old role in a gentler fashion. The moonlight is merely sunlight reflected, and under a full moon, you might notice your own shadow following you, faint and blue-grey. It's a softer version of your daytime shadow, like a quiet echo of the day. Trees and buildings on a moonlit night throw delicate, ghostly shadows on the ground. They lack the sharpness of midday, but they have a magic of their own. Walking by moonlight, you tread among these silvery outlines, almost as if wandering in a dream. The moon, in its quiet way, is continuing the conversation of light and shadow after the sun's departure, reminding you that even at midnight, the language of shadows still whispers. Now, once any stray moonlight has faded and true darkness has settled, the direct shadows have vanished, but the memory of their final positions lingers in your mind's eye. They told the story of the sun's departure. They reached out, grew dim, and finally faded, a silent narrative of day turning to night. In the darkness now, you might run a hand along the ground where your shadow once was, remembering how it slowly moved and stretched, alive with the sun's touch. Even now, though unseen, you stand within Earth's vast shadow. Night is the great shadow of our planet, enveloping everything around you. Knowing this, you feel cradled by the Earth itself, as it shields you from the sunlight until a new dawn. The language of shadows has finished its gentle tale for today, promising to return with the morning sun. Now that darkness reigns, the sharp outlines of the day are gone, but a different awareness awakens. With your eyes adjusting, you start to sense subtle patterns rather than bright forms. Perhaps you recall the spiral of a shell you saw once, or the perfect symmetry of a flower's petals earlier today. In the quiet of night, such natural designs come to mind unbidden. There is a gentle mathematics to the world around you, patterns and shapes that persist, waiting quietly to be noticed when you have time to truly see them. Sitting in the darkness, you become aware of the gentle order woven through the natural world. There are shapes and structures that repeat, patterns that echo softly from a seashell to the stars. In the daylight, perhaps you picked up a seashell and noticed its form, a spiral curve starting tight at the center and unfurling outward, growing but never changing its shape. That same graceful spiral can be found in unexpected places. It's hidden in the arrangement of seeds in a sunflower's heart, and in the curve of a snail's shell. Amazingly, if you could gaze from far above, you'd see a similar spiral pattern in the sweep of our galaxy, where countless stars swirl around a center in a vast cosmic spiral. It seems the universe favors this shape, from the small and delicate to the immense and star-filled. Nature's love of patterns appears in countless forms. Imagine a sunflower. Its dark center is packed with hundreds of seeds. Rather than a chaotic jumble, the seeds are arranged in neat spiraling rows radiating from the center, one set of spirals going one way and another set interweaving the other way. If you trace them with your eyes, you find each spiral winding gracefully outward. This clever design lets each seed have just enough room, an efficient packing that follows a quiet mathematical rule. Though the flower never does any calculations, it embodies a solution nature found eons ago. It simply grows that way, and the result is both useful and beautiful, a harmony of form and function. Think of a pine cone or a pineapple. Similar spirals wind around them too. More examples of this hidden order. Count the points or the sections, and you might find special numbers repeating. The kind of numbers that often turn up in living things, like 3, 5, 8, 13. These are part of the Fibonacci sequence, a series that crops up often in living forms. These numbers are part of a sequence quietly tucked into many growth patterns. But you need not do any arithmetic to appreciate it. You can just run your fingers over the overlapping scales of the pine cone and feel how each scale fits between others in a pleasing, regular way. Your mind finds comfort in that regularity, even if you don't consciously measure it. It's as if our very senses can recognize the quiet mathematics in these natural designs. Symmetry is another gentle rule that nature enjoys. Consider the petals of a simple flower. Many have 5 petals, arranged in a radial symmetry, like a little star. If one petal were missing, the balance would feel off. But with all 5, there's a satisfying completeness. Some flowers have 3 petals, or 6, or 8. Often these numbers are the same ones that appear in those spirals. A starfish in the ocean has 5 arms, each one similar to the next, fanning out evenly. Snowflakes, if you've ever seen one up close, almost always form 6 delicate branches. Each branch of a single snowflake is a nearly identical pattern, so that the snowflake has a hexagon symmetry overall. No 2 snowflakes are exactly alike, they say, but each one individually carries that 6-fold mathematical signature, born from the angles of water molecules bonding as they freeze. In a honeycomb, bees build with perfect hexagons, each cell identical, fitting together without any gaps, a naturally efficient use of space that follows geometric logic. These forms surround us, quiet and unannounced, yet somehow when we see them, we feel a sense of pleasing order. There is also a fondness for branching patterns. Consider the limbs of a tree spreading into the sky. Every big branch gives rise to smaller branches, which split into twigs, much like a river dividing into streams and creeks. Hidden underground, the tree's roots do the same, branching and rebranching to reach water and nutrients. Amazingly, our own bodies echo this design. Our blood vessels branch into smaller and smaller capillaries, delivering life-giving blood to every cell, just as a tree's branches deliver sap to every leaf. This tree-like pattern appears at many scales, a natural solution wherever something needs to flow or spread efficiently. It's a quiet marvel of design that repeats in forests, river deltas, and within ourselves. Even in the darkness of night, you can think of the patterns above and around you. The stars sprinkled across the sky might look random at first, but our minds connect them into constellations, patterns of our own making, reflecting the human tendency to find shape in chaos. Beyond those, on a larger scale, scientists discovered that stars collect into immense pinwheels of light. Galaxies, shaped like the spiral of that seashell, repeating the motif of a spiral over and over in the universe. And galaxies themselves cluster in filaments across space, like cosmic webbing, another pattern emerging when viewed from a great distance. It's astonishing to realize that from the spiral in a snail's shell to the spiral arms of a galaxy millions of light years away, there is a commonality. There is a thread of structure that runs through the fabric of nature. You don't need to know any equations to sense this gentle mathematics. It reveals itself in visual harmony and balance that feels soothing to the soul. Maybe you have subconsciously noticed how leaves on a stem are often arranged in a spiral up the branch, each leaf positioned just offset from the one below so that it catches the sunlight. A quiet optimization that the plant grew into being. Or how the coastline seen from above traces a fractal-like outline, with smaller bays and peninsulas resembling the larger shape, repeating patterns in endless variation. These patterns are not cold or strict. They often have a softness, a natural variation that makes them even more inviting. Like a lullaby has a repeating melody that calms you, the patterns in nature have a repeating logic that reassures. Even the melodies of a soft lullaby or the meter of a poem follow mathematical patterns. A soothing song might have a repeating rhythm and harmonious intervals that please the ear, all based on ratios and counts that our brains instinctively recognize as pleasant. When you tap your foot or feel your heartbeat align with a gentle song, you are actually syncing up with its numerical pattern, without ever needing to think of it as numbers. Music is like audible architecture, built on patterns of time and tone, yet it touches our heart more than our intellect when we hear it. This too is a quiet wonder, that something as abstract as mathematics can become as intimate and warm as a favorite song in the night. The structure underpinning a lullaby is akin to the structure behind a seashell's spiral or a star's orbit, organized and precise, but resulting in pure comfort and beauty. In this gentle night, reflect on how connected everything is through these subtle designs. The universe is not a chaotic, unstructured place. It's full of rhythms and shapes that rhyme with each other. The curl of ocean waves, the rings inside a tree trunk marking each year, the orbits of moons around planets. All of them are guided by physical laws that manifest as patterns we can observe. There's something deeply comforting in that. As random as life can seem, it eases the mind to know there's an underlying order, a reliable cadence to many things. Lying back and gazing at the sky, you might even notice the faint band of the Milky Way on a very dark night. It arches across the sky in a glowing band, our own galaxy seen from within. Even though you cannot see its spiral shape from here, you witness another pattern, the concentrated line of stars marking the disk of our galaxy. It's another hint of structure in the heavens above. Let these patterns wash over your thoughts gently. In the quiet, you can almost feel the numbers and shapes around you, not as calculations, but as comforting, familiar friends. The world has an innate orderliness, from the spiral of a shell at your feet to the spiral of a galaxy overhead. This quiet mathematics of nature is like a soft-spoken assurance that there is balance in the world. And as you appreciate these delicate designs, you become part of that harmony too, breathing quietly in time with the subtle patterns all around. The night has its own gentle rhythm, and for as long as people have watched the stars, they have sought ways to measure the hours of darkness. Without the sun in the sky, our ancestors turned to more subtle clocks. Imagine an ancient temple or observatory late at night. All is quiet, save for the soft drip of water into a bowl. This is a water clock, or clepsydra, steadily counting time, drop by drop. Each drip and ripple marks a moment passing, a gentle and fluid ticking in the silence. By calibrating how much water flows in an hour, watchers of the night could keep track of time long after the sun had set. In a world before mechanical clocks, this simple device was a marvel, a way to capture time's passage using the most basic element, water, flowing endlessly and calmly. Elsewhere, perhaps in a sailor's cabin or a scholar's study, an hourglass slowly trickles sand from one glass bulb to another. The fine sand slips in a narrow stream, collecting silently in the lower chamber. If you listen closely, you might hear a very faint hush as the grains cascade, like a tiny whisper. Each grain of sand is like a second, and together they measure out minutes and hours. When the top bulb empties, someone simply flips the glass to start the flow anew. The hourglass doesn't tick or chime, it measures time in near silence. You might only notice it when you glance at the diminishing sand, realizing that another portion of the night has gently drifted by. It's a peaceful image, a lone observer by candlelight, turning the hourglass and noting the hour while the rest of the world sleeps. Over the centuries, people invented more timekeepers to mark the night's progress. Candles were crafted with markings, so the length of the burned wax could show the hour. Some burned incense sticks, with different scents for each watch of the night, so that even by fragrance, one could tell the time in darkness. Each innovation was a quiet companion through long evenings, dividing the night into manageable pieces. These devices reassured those awake in the small hours that time was still flowing, even when the sun's guidance was gone. Eventually, mechanical clocks joined the scene, bringing a steady ticking heart into homes and towers. Consider an old grandfather clock standing in a dark hallway at midnight. Its pendulum swings back and forth with a soft, methodical tock. Tick, tock. Each swing is so steady you could set your heartbeat to it. Inside, gears turn with patient precision. Every second, every minute is counted and remembered by this clever machine of springs and weights. The tick-tock becomes a comforting background lullaby, affirming that time is being kept faithfully. In the quiet of night, that steady tick is like a friendly reminder that the world is still turning on schedule. It was discovered, quite by accident, that a pendulum of a given length swings in a constant rhythm. In an old cathedral, a keen observer once noticed the chandelier overhead, swaying gently, and realized each swing took the same amount of time, whether the arc was large or small. He counted the swings against his own heartbeat, and from this simple, silent experiment came the understanding that a pendulum could be used to keep time. Harnessing this principle, clockmakers built pendulum clocks that divide time into equal beats. The gentle swing you see now in the grandfather clock is a result of that discovery. Gravity's pull giving the pendulum a steady cadence that measures each second with faithful consistency. Picture a quiet village square centuries ago, a moonlit night where most windows are dark. In the tall clock tower, a bell chimes softly to signal midnight. The sound echoes briefly through the empty streets and then fades. leaving the night as silent as before. Those few awake might nod to themselves. Another hour passed, the world turning onward. Then they perhaps return to their stargazing or their thoughts, comforted that time is in order. In some towns of old, a night watchman would roam the streets at this hour, lantern in hand, to ensure all was well. At each hour, he might call out the time or give a gentle clang on a bell, a human reminder of order in the darkness. Midnight and all's well, he'd announce to sleeping households. Those few awake could hear his distant voice and feel comforted that someone watched over the sleeping town. The steady progression of the hours was tended to, and they could close their eyes knowing the night was being gently overseen. Timekeepers of the night have always been humble instruments. Dripping water, falling sand, a swinging pendulum, the slow dance of stars. They don't demand attention with loud alarms. Instead, they quietly assure us that even in darkness, the flow of time remains constant. In a way, they teach patience. You can't hurry the sand in an hourglass. It will flow at its own steady pace. Watching it can almost be meditative, each grain a tiny reminder to slow down. In these quiet hours, you might notice that your own sense of time changes. Minutes feel slower, gentler. With fewer distractions, each moment stretches comfortably. An hour at night can feel like a small eternity of peace. There is no hurry in the darkness. The ticking clock is not a tyrant, but a companion. You can simply let the time flow, second by second, like the sand in the hourglass, without concern. The night encourages a different relationship with time, one that is patient and forgiving. Wrapped in darkness, you have permission to lose track of minutes and just exist, breathing in sync with the subtle ticks and tocks that mark the passing night. As you rest in the deep of night, you might imagine the soft tick of a clock, or the drip of a clepsydra marking the moments. Each tick or drop is like a gentle heartbeat in the silence. They measure something we often feel in the still of the night, the slow, even passage of time, guiding us toward morning, one quiet second at a time. Together with the distant movement of the stars, these timekeepers weave a tapestry of rhythm in the darkness, connecting our human sense of time to the grand motions of the cosmos above. Between each measured tick of the clock, a hush fills the space around you. That silence itself becomes profound at this late hour. Now the timekeepers can recede into the background of your awareness. You are left with the soft, enveloping quiet of the night. In this silence, every tiny sound, no matter how distant or subtle, finds your ear. You listen, and you begin to hear the night's own gentle voice. When you first listen to the night, you might think it's completely silent, but as you give it more attention, the silence itself seems to have texture. In the stillness, your ears begin to catch the subtlest of sounds. You can hear your own slow breathing and maybe the soft thump of your heart if you concentrate. The world is so quiet that even these intimate sounds stand out. Then, gradually, other whispers make themselves known. The faint rustle of a breeze through leaves, the tiny scurry of a night creature in the grass, or the distant call of an owl echoing from somewhere in the dark. Each sound is delicate, spaced out by long moments of pure quiet. You realize the night isn't silent at all. It's just that its sounds are gentle and few, like sparse stars in a dark sky. The quiet of the night gives each noise a special clarity. In the daytime, those little sounds would be lost in the din of activity. But now, they unfold in their own spotlight of attention. Imagine standing by a calm lake under the stars. The water is utterly still. If you drop a pebble, the splash rings out sharply, and you can hear the ripples lapping long after the stone is gone. Even a soft whisper of your voice can carry across the water, bouncing back as a faint echo. The air is cool and stratified. There's no warmth rising off the ground to churn it. In this stable air, sound travels farther and straighter. A murmured conversation on one side of a quiet lake might be heard clearly on the other side at night, when by day it would have been drowned by background noise or scattered by turbulence. Have you ever noticed how distant train whistles, or a dog barking far away, seem more audible at night? It's not just your imagination. The physics of nighttime air often allows these sounds to reach you. The ground has cooled, and the air near it is colder than the layers above. This creates a gentle inversion, like a blanket of cool air that hugs the earth. When sound travels through such layers, it bends back downward instead of upward, keeping it close to the ground, so a far-off train's horn can glide through the still night air for miles, its sound waves guided along by the cool layers. What you hear is a softer, drawn-out version of the sound, stripped of its harsh edges by distance and the hushed atmosphere. It arrives at your ears as a lonely, haunting call in the darkness, reminding you that the night links distant places with threads of sound. In a similarly still night, you might hear your own voice returning to you. Say you stand in an open field or at the edge of a canyon under a blanket of stars. If you speak softly, just a gentle hello, you may hear the faintest of echoes after a short pause. It's as if the landscape itself whispers back. You are momentarily connected with the vast, quiet space around you. In a deserted street at midnight, a simple cough or footstep can seem surprisingly loud as it echoes off sleeping houses. These echoes aren't raucous. They are subtle, fading quickly into the silence again, as if reminding us to keep the hush intact. The smallest sounds become noticeable now. The creak of a settling floorboard in your home sounds like a loud announcement in the stillness. A drip from a faucet in the next room ticks like a tiny clock. If a page of a book is turned, the gentle crinkle is as pronounced as a bird's flutter. Each sound appears, makes its gentle mark, and then vanishes, leaving you once more in silence. Rather than being jarring, these sounds are comforting in their familiarity. They emphasize just how peaceful the environment is, that such little things can be heard at all. Out in nature, a chorus of subtle noises often replaces the hum of daytime activity. Crickets might chirr softly in the grass, their rhythm steady and soothing, a natural lullaby in the background. Perhaps frogs by a pond pluck single notes into the night air, spaced widely apart. An owl's hoot resonates through a grove of trees. Then nothing answers, and silence returns. These sounds are spaced out in time, giving you long stretches of calm in between. Your ears begin to relish the quiet intervals as much as the sounds themselves. It's like a slow musical piece, with more rests than notes, a composition in silence. On winter nights when the ground is blanketed in snow, the silence deepens further. The snow absorbs sound like a great muffling cushion. If you step outside, your own footsteps make only a soft crunch that is quickly swallowed by the still air. No insect hum, no rustling leaves, just an almost magical quiet. Under a bright moon, the snow-covered landscape glows gently, yet remains utterly hushed. Such nights feel especially peaceful, as though the world is sleeping under a cozy white quilt and you are walking through a silent dream. In the dead of night, if you find a place truly removed from human noise, you can encounter a silence so complete that it feels profound. In such moments, you may even hear the internal sounds of your own body more clearly. A swallow, a breath, your heartbeat in your ears. This nearly absolute silence is rare and can feel almost weighty. It heightens your other senses too, as if your body is stretching its ears outward, eager to catch any hint of a sound. In this deep quiet, just a single leaf falling or a distant twig snapping becomes an event. Such profound quiet has often been cherished as sacred. In ancient monasteries or remote hermitages, monks would keep vigil through the midnight hours in almost complete silence, believing that in the absence of worldly noise, they could hear a higher voice or simply find inner peace. Indigenous peoples, too, have listened to the night's silence as a guide, attuning to nature's subtlest cues, the approach of distant rain, the movements of animals, or the stirring of their own hearts. In these deep, wordless moments, the boundary between the self and the world seems to melt away. You become just another gentle element of the nighttime scene, as natural and quiet as the trees and stars around you. The silence welcomes you into a calm communion with all that is. Listening to the silence of the night is a form of meditation. It anchors you to the present, making you acutely aware of the here and now. The fewer the sounds, the more expansive the world feels. You realize just how large the night is around you. Every tiny noise paints a mental picture. The location of a small animal, a breeze moving through a specific tree, or the gentle ripple in that lake. You find yourself appreciating the texture of each sound against the backdrop of silence. Ultimately, the quiet night teaches your ears to be sensitive and patient. In the absence of constant stimulation, you discover an entire landscape of subtlety. The silence isn't empty, it's filled with possibility. It invites your mind to slow down and your ears to reach out. And as you lie there or sit in the darkness, the hush itself becomes like a gentle lullaby. It's the universe saying, "Rest now, you are safe, and the world is calm." In that assurance, you can close your eyes for a moment, knowing that in this silence, everything is at peace. You remain still, perhaps curled up in a comfortable spot, letting the silence wrap around you like a soft blanket. The urge to talk or move fades away. You are entirely present in this quiet moment. In this silence, you realize there is nothing you need to do and nowhere you need to be. The night has granted you permission to simply exist, peacefully and unhurried. Enveloped by the calm, your mind grows as quiet as your surroundings, and a profound restfulness settles over you. While you were immersed in listening, your eyes were quietly adjusting to the darkness. Now, as you slowly open your eyes wide to the night sky above, you realize the darkness isn't empty at all. It's filled with countless tiny lights. Stars that were once hidden now peek out, each minute revealing more of them. Your vision has grown more sensitive in this extended darkness, allowing you to see the faint shimmer of starlight that was invisible before. It's as if the longer you stay in the night's embrace, the more the universe reveals itself to you. As you gaze upward, you find yourself seeing more and more stars the longer you look. Your eyes have slipped comfortably into night vision mode. In the first minutes of darkness, only the brightest stars and planets were visible. But now, after a half hour or so beneath the dark sky, countless fainter stars have blossomed into view. Your pupils are wide open, embracing what little light falls upon them, and your retina has undergone a delicate chemical change to become far more sensitive. The world has faded to shades of grey because your colour-sensing eyes have given way to the light-sensitive night vision cells. But in exchange, you can now see the once-hidden starlight. What was a sparse sprinkle of stars earlier is now a rich dusting, like diamond powder tossed across the vault of the sky. The transition to full dark adaptation is so gentle you hardly notice it happening, until you suddenly realize you can see outlines and shadows again, illuminated only by starlight. The Milky Way reveals itself as a pale, milky band arching high overhead if you're far from city lights. At first, you might not have seen it at all. It was too faint. But now, it emerges as your eyes attune to the darkness, a ghostly river of light comprised of uncountable distant stars, all merged into a soft glow. Each minute in darkness uncovers new details. A particularly dense knot of stars here, a faint smudge of star cluster there. You are literally seeing deeper into space with each passing moment of keeping the lights off and simply watching. This is the quiet skill of stargazing, patience and attentiveness. Ancient sky watchers knew to wait and let the night vision come to them. They would avoid bright flames or lights once the stars were out, guarding their precious night sight. Some even used red-tinted lamps or covered one eye if they had to check a lit map, because they understood that one flash of bright light could erase many minutes of dark adaptation. You too, protect your eyes now, keeping them directed upward, immersed in the darkness, so that more celestial points continue to appear. With the sky now fully open to you, you can practice the gentle art of mapping the heavens. You start by picking out a cluster of stars that form a familiar shape. There, those 7 bright stars form what looks like a ladle or a plough, the Big Dipper. It hangs in the sky recognizably, a comforting signpost in the night. You trace its shape slowly with your eyes, perhaps even lifting a finger to draw the outline in mid-air, from the handle to the bowl. Now, using it as a guide, you extend an imaginary line out from the 2 stars at the end of the bowl. Following that line, your gaze comes to rest on a lone, modest star. That star is Polaris, the North Star, quietly glowing above the northern horizon. It's not the most brilliant star, but it holds a special place. It marks the direction of north and barely moves as hours pass, while all other stars circle around it. Finding Polaris by such a simple star map trick gives you a small thrill, like you've unlocked a secret in the sky. You now know your cardinal directions just by looking up, an age-old navigation method unfolding gently before your eyes. Encouraged by this success, you seek out other patterns. To one side of the Dipper, you notice a W-shaped configuration of stars. That's Cassiopeia, the queen on her throne, another marker that wheels around the North Star opposite the Dipper. Her zigzag of 5 stars is distinctive. Once you see it, you can't unsee it, and it joins your mental map. Turning your head slowly, you look for more. Perhaps high above, almost overhead, you find a bright star with a bluish tint. It's Vega, part of the summer triangle, if you're in that season. Nearby are 2 other bright stars that complete the triangle, Deneb and Altair. They form a great triangle shape that spans a huge part of the sky. By connecting these points, you anchor another large region of the heavens in your mind. Little by little, you draw connections between the stars, like a cosmic connect the dots. A curved line of stars becomes the handle of a teapot shape in Sagittarius. A tight cluster of tiny stars looks like a miniature dipper. The Pleiades, also known as the Seven Sisters, come into view like a tiny sprinkling of jewels. If you look slightly to the side of that cluster, using a trick called averted vision, suddenly a few more of the sisters pop out, since your peripheral sight is more light-sensitive than the center of your gaze. With this gentle technique, you discover that looking just off-center from a dim star makes it appear brighter. It feels like a magic trick, but it's really just understanding how your eyes work in the dark. You smile to yourself as yet another faint star comes into view when you glance slightly away from it. Every new pattern you recognize turns the once overwhelming dome of stars into a friendly map. You recall that early explorers and sailors learned the sky in exactly this way, memorizing one constellation at a time until the whole sky was as familiar as a well-known road. Under this quiet sky, you follow in their footsteps, or star steps, tracing out the same star patterns that others did long before you. In fact, imagine someone in your place, hundreds or even thousands of years ago, lying back on a clear night, almost exactly like this one. They too would have pointed out Orion's belt, or the dipper in the sky, perhaps telling a child or a friend the names and stories of these stars. The constellations you recognize tonight are largely the same ones recognized by ancient farmers, sailors, and poets throughout history. You are sharing in a timeless human tradition of stargazing. This realization weaves a thread of connection between you and all those stargazers of the past. Across ages and cultures, the quiet act of mapping the stars has offered the same comfort and sense of belonging to the universe that you feel now. You are never truly alone under the stars. You're accompanied by the dreams and curiosity of countless others who have looked upward from this earth and felt the same gentle awe. The more you search, the more you find that the sky is full of stories and guides. There are stars that form the outlines of mythical heroes, creatures, and gods, the lore of constellations that humans have imagined for millennia. But even without knowing those tales, simply recognizing the geometric patterns, a triangle here, a square there, like the Great Square of Pegasus, gives you bearings. It turns an endless random scatter of lights into an organized, knowable panorama. As the months pass, the sky itself gradually changes like a slow turning page of a book. Constellations that dominate one season will give way to different star groups in another. The map above is not static. It shifts a little each night, with stars rising roughly 4 minutes earlier each evening. Over weeks and months, these small changes add up. Orion, for instance, rules the winter nights, his belt gleaming on crisp January evenings. But by summer, Orion has set with the sun, and the Scorpion constellation, Scorpius, crawls across the warm July sky in his place. Each season brings a new chapter of familiar patterns. The bright star, Sirius, sparkles in winter, while the grand arc of the Milky Way stands tall on summer nights. Early peoples attuned to nature used these cosmic changes to mark time and know when to plant or harvest. They recognized that the sky was a calendar as well as a compass. By mapping the stars through the year, you not only find your way on a given night, but also connect with the cycle of seasons. It's reassuring to realize that when these stars return to the same spot in the sky next year, a full cycle of life will have gently unfolded here on Earth once more. You're witnessing time and space interwoven in the dome above. Ancient travelers and navigators learned to gauge time by the stars' positions, using them much like a living clock face in the sky. There is something profoundly reassuring in how cyclic and dependable it all is. No matter how still and quiet the night becomes, these subtle movements persist. Each time you identify another constellation or star, you mentally draw it into your personal night sky map. Over time, these maps in your mind expand, and you start to see how one constellation leads to another, how the whole dome connects. What once was an unknowable expanse becomes as cozy as a hometown neighborhood. Each cluster of stars, like a neighbor's house, lit softly in the dark. Mapping the dark brings a sense of comfort and place, even in the vastness of night. Interestingly, different cultures connected these stars in their own unique ways, drawing different pictures in the sky. The figures you know, like Orion and Cassiopeia, are from one tradition. Far across the world, others saw these same stars and imagined entirely different scenes. Perhaps a drum, or a great canoe, or a gathering of campfires. Polynesian sailors, for instance, used the patterns of stars not as mythological figures, but as precise maps to navigate the open ocean. In ancient China, the night sky was divided into celestial palaces and gates with their own stories. Each culture wove its life and legends into the starry tapestry overhead. And yet, despite the differing pictures and tales, they were all gazing at the very same stars. There's something profoundly unifying in that thought, that throughout history, humans everywhere have looked up in wonder at the night sky, each finding familiar shapes and comfort in the lights above. As you continue this gentle exploration, you prepare yourself for an even deeper journey, one that goes beyond the simple patterns and begins to wonder at the nature of those stars themselves and the immense distances and mysteries that lie out among them. Now that the sky has become an old friend full of recognized patterns, you begin to wonder about the stars themselves. Each one of those pinpoints of light is a doorway to a faraway place and time. In your mind's eye, you step through one of those doorways. Take Orion, which you greeted like a familiar companion, the shimmering star that marks Orion's shoulder. You recall its warm reddish hue. That star is Betelgeuse, a red supergiant many hundreds of light years away. It's so large that if you placed it where our sun is, it would swell out beyond the orbit of Mars, engulfing all the inner planets. Someday, in the distant future, Betelgeuse will end its life in a tremendous supernova explosion. But tonight, as it has for millennia, it glows softly, a coal-like ember in Orion's form, benign and steady to your eyes. Just below it, you see Orion's belt of 3 stars in a row, and hanging from the belt, the sword of Orion, where a faint patch of light resides. That little blur isn't a star at all, but the Orion Nebula, a vast cloud of gas and dust. Within that nebula, new stars are being born even as you gaze at it. Though to your unaided eyes it's barely a misty speck, in truth it's a stellar nursery 300 light years away, glowing with the collective light of baby suns. When you realize this, the constellation of Orion transforms from a simple outline to a portal into deep space, a hint that the calm figure you see belies extraordinary cosmic processes happening unimaginably far away. Every constellation has these secrets. The Big Dipper's handle has a star that, upon closer look or with a bit of magnification, splits into 2. A double star system dancing around a common center of gravity. That unassuming point of light is actually two suns locked in orbit. The star at the end of the Dipper's bowl, Doobie, is actually 120 light-years distant from us. Its light started travelling toward your eyes before the modern age began. Cassiopeia's brightest star, Shedah, shines from 230 light-years away. The photons hitting your eye left that star around the time of the American Revolution. The night sky is a time machine. Each star a traveller from the past, reaching you only now. When you think about it, looking up is like reading an ancient, slowly updated story written in starlight. Among the stars you mapped, some are not stars at all, but planets visiting the night. That steady golden light over in the south could be Saturn, a world with magnificent rings, reflecting the sun's light from nearly 1 billion miles away. That intense bright point with a gentle yellow glow might be Jupiter, the giant of our solar system. Unlike stars, planets don't twinkle as much. Their disks are tiny but substantial, so the atmosphere doesn't make them flicker like it does the distant suns. Knowing this, you realize that the sky you've been mapping is a mix of nearby neighbors and far-flung suns. It's like a vast neighborhood with both our immediate planetary family and the distant lights of other communities. The more you look, the more depth you perceive. Between the constellations, you might notice a faint smudge of light, almost too subtle to catch. There, near the constellation Andromeda, lies the Andromeda Galaxy, the closest spiral galaxy to our own Milky Way. To your dark-adapted eyes on a clear, moonless night, it appears as a tiny, oval blur. Yet that faint glow is the combined light of 1 trillion stars, 2.5 million light-years away. In other words, the light you see began its journey long before humans were even around to see it, back when early ancestors walked the earth. Now, after that eon-long voyage, a tiny fraction of that galaxy's light has reached your retina. You have, in a very real sense, seen another galaxy with your naked eye. It's humbling and wondrous. A doorway to an entire universe beyond our own opens for you, quietly, as you lie under the sky. These realizations come gently, not all at once, but as a gradual deepening of your understanding while you relax under the stars. Each star and faint fuzz you recognize connects you more to the cosmos. You start to feel the scale of it, but it doesn't frighten you. Surprisingly, it comforts you. The stars are distant and vast, yet here their light is caressing your eyes, bridging the gap between worlds. You feel a kinship with these lights. After all, our sun is a star too, one of the countless points of light in someone else's night sky. That thought makes you smile. Our sun, which so dominantly lit our day and painted our sunset, is just another quiet star in the grand scheme. Under the cover of night, all stars, including our own, play together in the sky, none outshining the others in your eyes right now. You might remember that the material of your own body, the calcium in your bones, and the iron in your blood was forged in the heart of stars that lived and died before our solar system was born. We are intimately connected to these cosmic furnaces. Far from feeling lonely in the face of the vast universe, you sense a profound connection. The same starry ecosystem that glitters above is within you as well. In this way, the beauty overhead is not just something distant, it's personal. We are made of star stuff, as some have poetically said. And here those stars are, watching over you in the night, ancient and yet somehow familiar. As the night deepens, the earth beneath you feels very gentle and small. You lie there, a tiny being on a quiet planet, gazing out into an ocean of stars. But you do not feel insignificant. Instead, you feel at peace and cradled by the very vastness that surrounds you. The sky is immense, but it has become a source of comfort. Each star is like a friendly beacon in an otherwise dark sea, and collectively they make the darkness warm and inviting. Your journey tonight has taken you from the simple pleasure of a cool breeze and lingering sunset, gradually outward to the map of the sky and now beyond, to truly fathom where you stand in the universe. You have moved from observing the earthly twilight to touching the edges of the galaxy with your mind. And yet, the experience has been quiet, gentle, and full of wonder at every step. There are countless more marvels out there. Planets with swirling clouds and moons of ice and oceans, nebulae birthing stars, galaxies colliding slowly over eons, mysteries and beauties we have only begun to glimpse. Here, in the stillness of your own corner of the night, you feel ready to float further into that great expanse. The calm you've gathered from the sunset, the night air, the silence, and the star patterns carries you naturally toward deeper dreams of space. Above you, the universe quietly invites you onward, star by star, whispering that whenever you're ready, there are more stories to be told among the planets and beyond. If your eyes grow heavy as you lie under this expanse, that's all right. The stars will continue their silent vigil whether you watch them or not. You can let yourself drift into sleep whenever you're ready, comforted by the knowledge that the night sky above is peaceful and unchanging. Each star will be in its place, gently shining when you close your eyes. In a way, they stand guard over your dreams, twinkling reassurance from light years away. For now, you can simply breathe in the awe, letting yourself drift among those distant lights in your imagination, comforted by their eternal presence. The night will watch over you as you journey onward, ever so gently, into the wider cosmos that awaits. A gentle hush falls over the evening as we continue our journey beneath the stars. In the quiet sky above, a familiar companion emerges, casting a cool silver glow. The moon rises slowly, its pale face serene and steady, watching over the night. We gaze up to find it in a new guise tonight, for the moon is ever changing, gliding through an eternal dance of light and shadow. Each night, it shows us a different aspect of its presence, a gradual shifting that has guided and comforted countless generations before us. In the beginning of its cycle, the moon hides in darkness. On those nights of the new moon, the sky remains nearly moonless and deep, stars shining unhindered by lunar light. But soon, a delicate sliver appears, a crescent that smiles low on the horizon after sunset. With each passing night, the crescent grows, tenderly expanding its glow. The moon's slow dance has begun, a patient twirl that will unfold over roughly 4 weeks, bringing the crescent to half, to gibbous, and then to full. This rhythm repeats like a soft lullaby in the sky, calming in its predictability and ancient in its origin. As the nights progress, the moon becomes a first quarter, half illuminated from our view, seeming like a bisected lantern hanging in the twilight. There is a comforting symmetry in this phase, the bright half balancing the dark half. We know instinctively that it is just one step in the cycle. Soon, the moonlight intensifies further, and the shape rounds out. When the moon waxes to gibbous, more than half of it glows, yet it is not fully bright. It's as if the moon is almost remembering its full brilliance, a gentle anticipation building in the night sky. The land below is bathed in a softer, more diffuse light than day, a reminder of the sun's reflection. Under this increasing lunar glow, shadows of trees stretch faintly across the ground, and nighttime creatures stir in a silvery world. Finally, the moment of fullness arrives. The moon becomes a radiant orb, rising at sunset and ruling the entire night. In its full phase, it looks down like a benevolent guardian. On clear nights, a full moon can be startlingly bright, casting moon shadows and illuminating clouds with a pearly light. There is a calm, yet awe-inspiring quality to standing under a full moon. The same moon our ancestors gazed upon in wonder and wove myths about. We might notice the face of the moon, the darker patches shaping the illusion of a visage or a familiar figure, the man in the moon, or perhaps a rabbit, as some cultures see. In this gentle light, one feels connected to those ancient stargazers, sharing a moment across time under the very same moon. Yet even at full, the moon does not remain static. Night by night, after the peak of full moon, it commences the waning journey. A soft nibble of shadow appears at one edge, and the bright disk begins to recede. The moon rises a little later each evening now, no longer appearing right at dusk as it did when full. Its face becomes gibbous once more, but this time the shadow encroaches further across its surface with each passing night. There is a peaceful acceptance in watching the moon wane, knowing that this is part of its natural course. The light gently fades as the cycle progresses, moving from gibbous to a last quarter half moon, hanging high in the late night, and then shrinking down to a delicate waning crescent, visible before dawn. In those pre-dawn hours, a slender crescent moon might grace the sky, sometimes accompanied by the faint light of earthshine, sunlight reflected from Earth faintly lighting the moon's dark side, a subtle glow completing the crescent's outline. It is a ghostly and beautiful sight, as if even the moon's darkened portion is whispering a last goodbye before the cycle completes. All the while, the moon keeps one face turned toward us. For eons, it has been tidally locked with Earth, spinning on its axis at just the right pace to always show us the same familiar near side. It is as if the moon is a dancer, always facing its partner, gliding through the routine of phases without turning its back. But this dance has a subtle twist, the phenomenon of libration. Over the course of the lunar month, the moon appears to gently rock and nod as it moves along its slightly tilted and oval-shaped orbit. At times we glimpse a bit beyond the eastern or western edge of the moon's face, or a bit more of the north or south. This subtle wobble is not something one notices in a single night, but over the weeks, careful observers can discern it. It is as though the moon is slowly shaking its head no in a most languid fashion, or bowing ever so slightly. Through libration, we on Earth get to peek around the corners of the moon's constant face, eventually seeing a total of about 59% of the moon's surface from various angles. The effect is gentle and almost playful, a reminder that even something that appears unchanging holds a small mystery of motion. The moon's slow dance of phases is synchronized with our concept of time in a deep way. The very idea of a month has its roots in the moon's cycle, around 29.5 days between one new moon and the next. For ancient people, this repeating pattern was one of the most obvious ways to mark the passage of time. They watched the crescent grow night after night and knew that roughly 12 such cycles would bring the world through planting and harvest and back to planting again. Under the calm guidance of the moon, early calendars were set. Each phase of the moon might have carried significance: new moons for beginnings, full moons for midpoints and celebrations, crescents for transitions. In some traditions, a full moon was a time to gather, to reflect, or to celebrate under the bright night sky. In others, certain full moons had names tied to seasonal events: the harvest moon, the hunter's moon, each quietly marking its place in the year's rhythm. There is something inherently soothing about witnessing the moon's phases. Perhaps it is the way they unfold slowly, without hurry, teaching patience to all who pay attention. No matter how hurried our modern world becomes, the moon will take its time to wax and wane, never rushing its delicate dance. One can look up on any clear evening and know that the shape we see is just one frame in a never-ending sequence. There's reassurance in that reliability. Even when clouds hide it for a time, we trust that above, the moon continues its cycle behind the veil and will return to sight soon enough. The continuity of the moon's dance is a comfort, a gentle constant through the flux of our lives. Imagine standing by a quiet lake on a clear night, the full moon high above. Its light trails a shimmering path across the water, rippling softly with the breeze. The scene is nearly silent, save for perhaps the rustle of leaves or the call of a distant night bird. On nights like this, the moon's presence is almost tactile. You can feel it in the glow on your skin and the silver-blue hues it casts on the landscape. Now imagine the nights a week later. The moon is smaller, the path of light on the water fainter. By 2 weeks after full, only a slender crescent may rise before dawn, giving just a gentle glint on the water's surface. In all these moments, the moon quietly influences the mood of the night. When bright, it lends an open, softly shadowed brightness to the world. When absent or new, the stars reign in a darker sky, and the cosmos feels deeper. We find beauty in both ends of this cycle, the bright and the dark, each with its own subtle atmosphere. Throughout history, the moon has been our companion, a source of wonder, myth, and guidance. We have given it many names and faces in our stories: a goddess, or god driving a chariot across the sky, a wise old grandmother, a fickle trickster, changing shape. These tales echo the awe and affection we hold for the moon's calming presence. On some level, perhaps we recognize that we owe a great deal to this celestial partner. The moon's steady gravitational embrace stabilizes Earth's tilt, lending our planet more gentle seasons than we might otherwise have. It tugs at our oceans, as we will soon explore, and perhaps even tugged at the human imagination, spurring us to look upward and wonder. The moon's quiet dance is a dance with Earth as well, locked in a graceful cosmic duet that has lasted billions of years. As the moon continues its silent ballet across the sky, we follow along, enchanted by the changing light. From new to full and back again, it teaches us the beauty of cycles and the patience of time. Each phase flows into the next, like notes in a soothing melody, a visual music for those who take the time to watch. And while the moon waltzes with light and shadow above, its influence reaches far below, to the very ebb and flow of our earthly waters, and the subtle rhythms of life that move in concert with its gravitation. Let's follow that gentle pull now, down to the ocean's edge, where the moon's influence touches our world in the form of tides. quietly guiding the waters in their own kind of dance. We arrive at the ocean's edge under the moonlit sky, where water and moonlight meet in a timeless ritual. The moon's silvery glow shimmers on the surface of the sea, and as it does, the great body of water responds. Slowly, almost imperceptibly at first, the ocean begins to rise toward the moon. It is as if the sea itself is reaching up in greeting, drawn by an invisible thread of gravity. This is the tide beginning its ascent, a vast yet gentle movement of water across the world's shores. In this quiet hour, one can imagine the oceans breathing in and out, a planetary lullaby conducted by the moon from above. As the night deepens, the high tide arrives, inch by inch. Along a calm beach, the waves creep higher on the sand, covering rocks that stood dry a few hours before. There is no sudden rush, just a gradual and patient filling of the shore. The moon, now high overhead, pulls at the ocean with the steady rhythm of a heartbeat. On the side of Earth, facing the moon, the water bulges toward it, creating a dome of ocean that we experience as the tide coming in. At the same time, on the far side of the Earth, another bulge forms, where the moon's pull is slightly weaker. There too, the sea rises. Between these two highs, the water is drawn away from other areas, causing low tides. The Earth turns through these bulges, and so coastal places feel the water rise and fall twice each day. It's a cycle as old as the oceans themselves, and it carries a sense of calming reliability. The timing of the tides is like a hidden clock woven into the fabric of day and night. If you visit the same stretch of coast the next day, you'll find the tide does not occur at the exact same hour as the day before. The high tide arrives roughly 50 minutes later each day. This quiet shift is linked to the moon's own orbit around Earth. Each day the moon rises later than it did the day prior, and the ocean follows suit, trailing the moon's schedule with faithful consistency. In essence, the seas keep time with the moon. In ages past, before modern clocks, coastal communities lived by this lunar clock, planning fishing and sailing by the height of the water and the phase of the moon. The words we use even reflect this connection. The tide and time share a common rhythm in language and law, reminding us that time and tide wait for no one. It is a patient clock, though, one that has guided life by a steady cadence for billions of years. Under the spell of the moon's gravity, the oceans perform a slow dance, flowing forward and then retreating back. When we think of a lullaby, we imagine a gentle song that soothes and sways, and gravity's pull creates just such a sway in the ocean's waters. In the stillness of midnight by the sea, you might hear the soft rush of water advancing, or the quiet hiss as it pulls away over pebbles. This is gravity's lullaby, the moon singing to the earth in the language of waves. The effect is not only beautiful, but vital. Tides stir the oceans, mixing waters and nourishing coastal life, just as a loving hand might rock a cradle. Countless creatures have adapted to this reliable pulse, their lives set to the rhythm of the turning tides. Along rocky tide pools, for example, little ecosystems depend on the tide's rise and fall. At high tide, ocean water floods these pools, refreshing them with nutrients and tiny creatures from the open sea. Small fish and crabs venture in with the incoming water, and anemones blossom open under the cover of the waves. When the tide recedes, the pools become isolated pockets of life, where only the adapted can survive until the next high tide. Yet they do survive, having synchronized their feeding and breeding cycles to the moon's schedule. Farther out on broad mudflats, you might witness shorebirds probing the wet sands eagerly for food in the hours after water withdraws, knowing that soon the feast will be over when the sea returns. Each movement of the tide grants opportunities and then gently takes them away, like the opening and closing of a grand theatre curtain on the stage of the shore. It is a continuous cycle of renewal, a balance of give and take, orchestrated by the moon's timing. Even some of the grand events of marine life are timed to the moon and tides. In certain warm seas, corals wait for the right phase of the moon to release their tiny eggs and sperm in one synchronized moment, often just after a full moon when the tides are high. On those nights, under a calm sea and a moonlit sky, millions of coral colonies spawn together, filling the water with a blizzard of new life, an underwater snowfall, all timed by the lunar cycle. On distant beaches, guided perhaps by ancient instinct, horseshoe crabs crawl ashore on spring nights around the high tides of the full and new moons. They choose those times when the water will reach further up the sand, giving their buried eggs a safe, moist cradle before the tide recedes. When the eggs hatch, the next cycle of high tides will help carry the tiny young back to the sea. These creatures are following schedules written not in clocks or calendars, but in the pull of the moon and the wash of the waves. Theirs is a clock of nature, steady and unhurried. The moon is not the only heavenly body that plays a part in this oceanic song. The sun, too, lends its gravity to the tides, though more softly compared to the moon because of the sun's great distance. Sometimes the sun and moon pull together, and other times they tug in different directions. During the new and full moons, when the moon, earth, and sun align in a straight line, the gravitational forces join hands. The moon's pull and the sun's pull combine to draw the seas a little more than usual, creating especially high tides and especially low tides. These are called spring tides, not for the season, but for the idea of the tide springing up. At those times, coastal dwellers may notice the difference. The water reaches a bit farther up the shore than on a typical day, and reveals a bit more of the seabed at low tide. Conversely, around the quarter moon phases, when the sun and moon are at right angles relative to Earth, the sun's gravity partially counteracts the moon's. The result is a more moderate exchange, with high tides not rising quite so high and low tides not falling quite so low. These are gently called neap tides. The very phrase carries a softness, as if the ocean is taking a smaller breath. Whether spring or neap, the tides continue in their familiar pattern. Only the amplitude of the rise and fall changes, like the volume of the lullaby being adjusted slightly up or down. Over the grand scale of time, the moon's gravitational lullaby does more than move the waters. It subtly influences the Earth itself. Each tidal cycle ever so gently tugs on our planet's rotation, working like an unseen brake. Long ago, Earth spun faster. Its days were shorter. But eon by eon, the moon's interaction has gradually slowed the spin of Earth, lengthening our days by tiny fractions of a second each century. It's an imperceptible change to any one generation, but over millions of years, those added moments have accumulated. In this way, the moon has been easing Earth into a slower rhythm, just as a calming melody might slow one's breathing. Simultaneously, the energy Earth loses from this braking transfers to the moon, nudging it ever so slightly farther away. The moon drifts about an inch or so farther from Earth each year, a leisurely retreat, as if conceding space while continuing to hold Earth's gaze. These changes remind us that even the most solid routines of nature are not static, but evolve in the slow dance of gravity and time. At a human scale, none of this disturbs our daily beach walks or the steadiness of the tides from one day to the next. We still find comfort in their constancy. The waves lap the shore in a known sequence, high tide and low tide, like the inhalation and exhalation of our planet's breath. How many travelers have stood by the sea at night, hearing the rhythmic surf and felt at peace? Perhaps it is because, unconsciously, we sense this great rhythm and fall into sync with it. The beating of our hearts and the coursing of our breath find a mirror in the larger heartbeat of the ocean. In listening to the pattern of waves, we resonate with something primordial and soothing. Time itself seems to slow down by the water's edge under the influence of the moon. Minutes stretch out in the leisurely advance and retreat of the sea. You might walk along a beach at dusk and then realize hours have passed as the tide moved around you. The ocean's pace encourages us to let go of hurry and move to natural time. Long after we leave, the tides will continue through the night and into the dawn, faithful to the moon's guidance. Under the gentle governance of the moon and the subtle hand of the sun, the oceans will keep rising and falling as our earth turns. It's a comforting thought that no matter the turbulence of human life, this ancient cycle persists undisturbed. The moon in its quiet glory orchestrates the tides without a sound, creating harmony between sky and sea. As we stand at the water's whispering edge, toes sinking into cool, wet sand, we can feel connected to the wider cosmos. The gravity that moves the ocean also holds us firmly to Earth, linking us to the moon above. In this interplay of lunar light and ocean water, we witness a direct conversation between our world and its celestial companion, a conversation in the language of motion and time. The tides remind us that we are part of a system, an Earth-Moon partnership that shapes the environment we call home. They teach us patience and trust in the cycles that carry on beyond our control. When we next see the moon hanging low and golden over the sea at sunset, we might think of the unseen force that gently lifts the waters toward it. That same force has subtly steered the course of life and even the length of our days. From the gentle rise of each wave to the grand span of geological ages, the moon's influence is pervasive, yet so softly exerted that it feels like a whisper. As our gaze drifts from the rolling waves back up to the sky, we reflect on how the moon's companionship with Earth shapes such fundamental rhythms. But the moon is not our only celestial partner in this cosmic waltz. There is another presence whose steady light and warmth guide the broader patterns of our lives. The sun, our very own star. Just as the moon has its cycles, the sun too has rhythms, though on a vaster scale, and a character that might surprise us with its own quiet side. We turn now from the water's edge to the daytime sky, to consider the gentle heartbeat of the sun and the quiet power it bestows on our world. The scene shifts to daylight, and above us, the sun hangs in a wide blue sky, a brilliant, life-giving presence that we often take for granted. We feel its warmth on our skin, see its light all around us, yet rarely consider that our star has a rhythm of its own. To our eyes, the sun seems constant, unwavering in its glow from one day to the next. It is easy to imagine it as a steady beacon that simply rises and sets, unchanging except for the colour show it gives at dawn and dusk. But behind that sunny facade, the sun has its own subtle pulse, cycles and seasons that play out slowly across years, and a quiet heart that beats in the vastness of space. Each morning, the sun returns to our sky, climbing from the horizon with a gentle golden light. At dawn, its rays are soft and kind, illuminating dewdrops on grass and painting the sky in hues of rose and orange. In these early moments, the sun feels tranquil, as if it too is waking slowly, bringing the world out of shadow tenderly. By noon, it shines high and strong, the source of bright daylight and energy that fuels plants and warms the earth. Yet even at midday, with all its intensity, there is a constancy to the sun's light that is comforting. Day after day, for ages untold, the sun has given this gift of light and heat, reliably and generously. Then as evening comes, the sun lowers once more, and its light mellows to a deep amber. The world exhales a sigh of relief from the day's heat, and the sky becomes a canvas of soft colours. We watch the sun sink and feel the air cool. In the fading daylight, there is a sense that the sun is resting, bowing out with one last gentle glow before night takes its turn. This daily rising and setting is the most familiar rhythm of the sun, a cycle of wake and rest that structures our very lives, lulling us to sleep and rousing us come morning. Beyond this daily cycle, the sun harbours longer, slower rhythms, ones we cannot perceive without careful observation over years. One of these is the cycle of sunspots, often described as an 11-year heartbeat of the sun. Sunspots are cooler, darker patches that occasionally freckle the sun's bright face. To the naked eye, the sun always looks smooth and uniformly bright, and indeed, one should never look directly without proper protection. But through the filters of a telescope, one might sometimes see these transient spots, appearing and disappearing over time. They emerge when the sun's magnetic fields loop up out of the surface, creating regions slightly less hot than their surroundings. During the peak of the sun's cycle, dozens of sunspots can dot the solar disk. During the quiet troughs, years might pass with barely a spot in sight. It is as if the sun breathes magnetically, waxing in activity and then waning in a slow and stately rhythm. When the sun is at rest in its cycle, at what astronomers call solar minimum, the face of our star is often unblemished. In those quiet years, the sun's energy output is steady, with fewer eruptions or flares. The very light we receive on Earth changes only by a small fraction, so we do not notice these variations in our daily life. But the space around Earth grows calmer. There are fewer solar storms riding the solar wind. The sun seems content to simply shine, untroubled by too many disturbances on its surface. Historically, there have been times when the sun entered an especially prolonged calm. For example, records show that in the 17th century, sunspots virtually disappeared for several decades in what is now known as the Maunder minimum. During that era, the sun's silence coincided with unusually cold winters in parts of the world, as if our star's quiet mood subtly touched our climate. While the connection is complex, it reminds us that even small changes in the sun's activity can have gentle echoes on Earth. In contrast, when the sun's cycle swings toward its active phase, the surface begins to liven up with more spots and flares. We might liken it to the sun stirring from a nap, becoming more playful in a cosmic sense. Dark sunspots appear, often in groups, and move across the sun's face as it rotates. For the sun, a full rotation takes about 27 days at the equator. Over days and weeks, one can watch spots grow, change shape, and then fade away. They are like temporary birthmarks on the solar surface, reminders that our star is dynamic, not static. Around those spots, the sun occasionally releases flares, bursts of energy and light, and sometimes great arcs of plasma lift off into space. Yet even these outbursts are part of the sun's natural cadence. They rise and fall like notes in a long, slow melody that spans over a decade for each verse. Despite these fiery events, the sun's overall behavior is remarkably even-keeled for a star. Many stars in our galaxy are far more tempestuous, especially in their youth. Young stars can erupt with massive flares that outshine their entire star for brief moments, or vary wildly in brightness. Our sun, by comparison, is a model of stability. At around 4.6 billion years old, it is a middle-aged star, settled into a steady pattern of burning hydrogen into helium in its core. This stage of life, called the main sequence, is long and uneventful, which is a fortunate thing for us. It means the sun's energy output changes very little on human timescales, providing a consistent environment for life to flourish. The sun does not visibly flicker or change from day to day. It shines with a calm, seemingly eternal assurance. In this sense, it is like a steady heartbeat in the sky, reliable and soothing in its constancy. Think of the sunlight streaming through your window on a quiet afternoon. The golden beam moves slowly across the floor as the hours pass, but its quality remains warm and steady. There is a tranquility in that sunlight, a promise that as chaotic as life can be, the sun will rise again tomorrow and bathe the world in light. Our ancestors, feeling the sun's warmth at dawn, might have seen it as a divine comfort or an ever-watchful guardian. They built monuments to mark its rising and setting points throughout the year, celebrating the solstices when the sun's path reaches its extremes. Cultures everywhere revered the sun for its steadfastness and life-giving power. It was both a clock and a compass, and in many mythologies, a benevolent deity crossing the sky daily in a shining chariot or boat. All these stories and rituals underscore a deep human recognition that the sun, in its reliable journey, offers a foundation of calm in our lives. To say the sun is at rest may sound odd given the ferocity of its heat and the ceaseless nuclear reactions at its core. In truth, the sun is a roaring furnace of plasma, with temperatures at its center reaching millions of degrees, and it constantly emits streams of particles and light. But from our vantage point, when the sun is tranquil in its cycle, it appears peaceful. The very light that can burn and blaze also gently caresses a leaf, helping it grow. The very radiation that can spark auroras in the polar sky is also what colors each sunrise and sunset in pastel shades. There is a duality to the sun, immense power on the one hand and nurturing constancy on the other. For a star, ours is wonderfully well behaved. We might imagine that in its middle age, the sun has found a comfortable balance, shining steadily with the wisdom of a star that has billions of years of life experience. On the sun's surface, even at its quiet times, one can observe a boiling texture if looking through a proper solar telescope. This granular appearance is caused by convection, hotter plasma rising and cooler plasma sinking in the sun's outer layers. It gives an impression of a pot lightly simmering. This gentle simmer is a far cry from the violent eruptions we know the sun is capable of at its peak activity. In the quiet phase, the sun seems content to simmer without boiling over. Watching the sun in such times, scientists note a sense of stillness in space weather. The solar wind, a stream of charged particles flowing outward, diminishes slightly, and Earth's magnetic field feels fewer disturbances. Satellites and power grids on Earth breathe a tiny sigh of relief as intense solar storms become less frequent. It is as though the sun's calm spreads a bit of ease throughout the solar system. Over the course of approximately 11 years, The sun will go from this calm state to a busy one and back again. It's not a perfectly regular clock, but a natural cycle that can stretch a bit longer or shorter. When the sun next reaches a quiet minimum, if you had the proper eye to see it, you might find an almost featureless star, glowing uniformly, a blank slate of blazing hydrogen gas. Then, as years progress, small spots emerge again, heralding the next active phase. This cycle has been ongoing for as long as we have records, and likely far longer, a testament to the cyclical nature of our star's inner workings. Just like the moon's phases, or the swing of the tides, the sun has its own pattern of activity and repose. The scale is different, years instead of hours or days, but it's a rhythm nonetheless, one that adds another layer to the tapestry of cosmic timekeeping. Even as the sun rests in a lull, it continues to sustain life with unwavering dedication. Plants turn their leaves to follow the gentle sun across the sky. Animals bask in its soft warmth on a cool morning. People find their moods lifted by a bright but calm sunny day, perhaps without ever pondering the star at the center of it all. There is comfort in blue skies and a mild sun, the kind of days that invite us to slow down and simply enjoy the light. Those are the days when the sun's quiet benevolence is on full display, when it feels like a loving presence watching over the world. Eventually, the sun will move out of middle age and into a more restless old age, expanding and changing drastically far in the future. But in our time, and for many millions of years to come, it will remain as it is now, stable, generous, and composed. In the story of the cosmos, our sun is a calm character, a reliable narrator, setting the scene each day. When you close your eyes on a bright afternoon, you can feel its gentle heat on your eyelids, and perhaps hear the faint buzz of life thriving under its glow. That is the quiet power of the sun, a strength that doesn't need to be loud to be effective. It simply is, and in being so, it creates the conditions for oceans to flow, forests to grow, and creatures like us to live and wonder. While the sun itself does not sleep, it gives us the gift of night by illuminating one side of Earth at a time. Every sunset is like the sun whispering, "Rest now," to half the world, even as it whispers, "Wake up," to the other half. That ceaseless cycle of day and night is a balance struck by Earth's rotation and the sun's steady shine. And on rare occasions, the sun's activity reminds us of its dynamic nature in more visible ways. Sometimes, even in its quiet grace, the sun sends out tendrils of energy that reach our world. When conditions are just right, particles from the sun dance with Earth's upper atmosphere, creating shimmering lights in polar skies. Those gentle illuminations, auroras, are the sun's nocturnal gift to our planet, a silent fireworks display that colours the darkness. Now, as our journey continues, we turn our attention to those high-latitude night skies, where solar whispers become curtains of light. Let us look to the poles and watch as the heavens drape themselves in glowing veils, the auroras of the north and south, quietly adorning the sky with the sun's subtle artistry. Far to the north, on a cold, clear night, the sky begins to perform a silent ballet of light. What was moments ago dark and filled with stars gains a faint glow along the horizon. A delicate green sheen appears, like the edge of an invisible curtain being drawn across the heavens. Slowly, it rises and extends, forming a shimmering arc high above. Then, as if stirred by an unseen breeze, the arc of light begins to ripple and fold, unveiling vertical streaks that reach toward the stars. These are the auroras, the northern lights, unfurling in the sky with ghostly grace. They drift and sway in complete silence, immense curtains of luminescence that transform the night into a dreamlike canvas. Under this ethereal display, the world below falls hushed. Snow-covered fields or still, dark forests lie in quiet witness to the spectacle overhead. The lights intensify, their colour a soft jade green that undulates like waves in a gentle sea. At times, hints of pink and violet edge the green, especially along the lower fringes of the curtains, adding depth to the palette of night. The aurora glows and pulsates, brightening, then dimming in a slow, mesmerizing rhythm. It is as if the sky itself is breathing in colour. One moment, the lights form a vast arch from horizon to horizon. The next, they break into patches and rays that dance independently. To an observer standing in the frosty air, perhaps bundled in a coat with breath steaming, the feeling is one of awe and tranquility. The heavens are alive, yet they make no sound. It is a spectacle that engages the eyes and the heart, leaving the rest of the world in profound quiet. These curtains of light are born from a union of earth and sun. Energized particles from the sun have traveled across space, riding the solar wind, and found their path guided by Earth's magnetic embrace toward the poles. There, high above in the atmosphere, they gently collide with atoms of oxygen and nitrogen. In these encounters, energy is released as photons, tiny bursts of light that collectively paint the sky in these glowing hues. It's a grand, invisible choreography turned visible. The sun's subtle breath upon Earth's magnetic field, made manifest in colour and motion. And while the science behind it is understood, knowing the cause does not diminish the magic. If anything, it adds a layer of wonder. How remarkable that disturbances on our star, so far away, can create such beauty in our sky, and do so in such a delicate and serene manner. Auroras often appear as towering draperies, folds of light hanging from above. Sometimes they form a corona, a crown of rays converging near the zenith, making it seem as though you are looking up into a luminous whirlpool of greens and purples. On other nights, they may simply be a diffuse glow, a quiet auroral mist that tints the sky without distinct shape. Each display is a bit different, and each carries its own mood. There are nights when the auroras dance quickly, curtains flapping and rays shooting in an excited burst of activity. Even then, from our distant vantage, they seem graceful, like flickering candles reflected on a ceiling. On other nights, the lights advance and retreat slowly, evolving over hours, allowing ample time to soak in their forms. One can lie back on a snowy hill, eyes fixed upward, and feel almost as if the sky has lowered a veil of colour to wrap around the world. Though we often speak of the northern lights, the southern hemisphere has its own identical twin display. In polar skies over Antarctica or the far southern oceans, the aurora australis casts its gentle spell in hues of green and red. Few people live in those remote southern latitudes to witness it, but the phenomenon is a mirror of the northern lights, gracing the other end of the world. It's humbling to think that at both ends of our planet, Earth is quietly glowing at this very moment, whenever solar particles are dancing through our atmosphere. The planet itself becomes a flickering lantern in space, crowned at top and bottom by these auroral rings. For those fortunate enough to have seen the auroras, the experience often defies words. There is a timeless quality to it. Indigenous peoples of northern lands have long woven tales about these lights. Some believed they were spirits of ancestors or animals playing in the night. Others saw them as a bridge between worlds or a message from the gods. Watching the auroras, one can understand why they inspired such stories. They feel alive. They shift and respond as if guided by intention, yet remain elusive and unpredictable. But unlike thunderous storms or flashing lightning, this space weather phenomenon is gentle. It doesn't frighten with noise or fury. Instead, it entrances, inviting calm reflection as you gaze upward. You might feel a quiet kinship with all who have ever paused to watch these same lights through the ages, sharing in a collective sense of wonder. The colours of the aurora are not like the harsh neons of human-made lights. They are soft, diffuse, often pastel in intensity. Pale green is most common, a green that can fade into white at the highest parts. Occasionally, when the aurora intensifies, deep scarlet reds may unfurl above the green, or rich purples might fringe the lower edges. These colours come from different atoms high in the atmosphere, oxygen giving off green and red, nitrogen contributing blues and purples, all blended by nature into a silent symphony of light. For the observer, it is as if the night has decided to mimic a slow watercolour painting, with pigments bleeding gently into one another across the canvas of the sky. There is no jarring movement, only flowing transitions. In the extreme quiet of a winter night near the Arctic Circle, you might even hear your own heartbeat quicken at the sight of a particularly bright auroral burst. Some people have wondered if auroras make sounds. For the most part, they do not, at least none that human ears can typically detect. A faint crackling or swishing has occasionally been reported during very strong displays, but these accounts are rare and their cause is debated. For the most part, the lights play out in silence, allowing other natural sounds to frame the experience. The crunch of snow underfoot, the distant howl of a wolf, or the gentle sigh of wind through pines. Such a setting reinforces the feeling that the auroras are a gift of peace, a reminder of the sublime and tranquil side of nature's power. Auroras tend to occur in cycles and patterns too, tied to the sun's activity. Around the years of solar maximum, when sunspots and solar flares are more frequent, the auroras tend to be more active, appearing further from the poles and in more vibrant displays. In quieter solar years, the auroras retreat closer to their polar homes and are a rarer sight in temperate latitudes. But whether bold or faint, frequent or rare, they remain a gentle phenomenon, more a whisper than a shout from our sun. They are space weather in slow motion, the kind you can watch unhurriedly, bundled in a coat with a warm drink in hand, eyes scanning the sky for the next wave of colour. As the night deepens and the geomagnetic activity wanes, the auroras might soften or pull back toward the horizon, eventually fading into the darkness once more. The sky returns to its normal state, strewn with stars, as if the grand performance has drawn to a close. You're left with memories of those drifting lights and a lingering sense of calm. The Earth's upper atmosphere will continue to glow imperceptibly to our eyes, with residual energy. But to us on the ground, the show has concluded until the next time conditions are right. And there will always be a next time. Perhaps the following night. Perhaps not for weeks or months. But inevitably, the auroras will grace the sky again. continuing a conversation between sun and earth that has gone on for eons. In the quiet that follows, we find ourselves looking again at the stars and noticing other steady lights in the darkness. Among them are a handful of wanderers, planets that slowly roam the night sky. Unlike the ephemeral auroras, these planets are constant companions, appearing night after night in nearly the same places, moving gradually over weeks and months against the starry backdrop. As the green curtains of the aurora close, our attention shifts to these enduring points of light: Mercury, Venus, Mars, Jupiter, and Saturn, ancient wanderers that have guided and intrigued sky watchers throughout history. Their gentle presence now beckons us to follow them across the heavens, continuing our night's journey with the serene company of the planets. High above the horizon after sunset, a brilliant point of light glints against the deepening blue. Not a star, for it does not twinkle. This is Venus, often called the evening star, though it is truly a planet, one of 5 wanderers known since antiquity. Venus shines with a steady silvery radiance, outshining all other points of light in the night. Nearby, if you know when and where to look, you might glimpse Mercury, a much fainter, fleeting spark that hugs the glow of twilight. Mercury darts close to the sun's vicinity and is visible only in the brief moments of dusk or dawn, a shy wanderer that appears and then quickly slips beneath the horizon. Together, these inner planets accompany the sun at morning or evening, offering a gentle companionship in the transitional skies of sunrise and sunset. As night falls fully, other wanderers make their presence known. High in the south on a clear night, a bright, steady beacon might catch your eye. Jupiter, the largest planet, casting a calm white light. Unlike the twinkling stars, Jupiter gleams with constant assurance. If you stare steadily, you'll notice it doesn't waver, a telltale sign of a planet's disk shining with reflected sun. Not far off, with a bit of effort, you might find a dimmer, golden-hued point. Saturn. To the naked eye, Saturn is not obviously ringed or distinct, but its yellowish light has a gentle quality, a little fainter and more reserved than Jupiter's bold glow. And then there is Mars, the reddish wanderer. At times, when Mars draws near to Earth in its orbit, it burns with a rusty orange intensity, unmistakable among the stars. At other times, it retreats to a modest glimmer, patiently biding time until its next close approach. These planets, Mercury, Venus, Mars, Jupiter, and Saturn, have been humanity's evening companions for millennia. They move on their own paths through the sky, each at its own pace, and ancient skywatchers quickly distinguished them from the fixed stars. The word planet itself comes from a term meaning wanderer, because these lights wander against the backdrop of the constellations. If you step out each clear night and mark a planet's position relative to a certain star, you'll see that after days or weeks, the planet has shifted its place. Mercury and Venus, being closer to the sun than Earth, always stay near the sun in our sky, and thus are visible only at dawn or dusk. They seem to flirt with the horizon, never straying too far from the sun's vicinity, as if tethered. Mars, Jupiter, and Saturn, however, range farther. They appear in different constellations at different times of the year, sometimes rising in the east as evening begins, other times already high at nightfall, depending on the year and their orbits. Jupiter takes about 12 years to make one grand circuit through all the constellations of the zodiac, lingering about a year in each. Saturn is slower still, needing nearly 30 years to complete its leisurely journey around the sky. Mars is quicker, completing a loop roughly every 2 years, which means every couple of years it returns to shine brilliantly in our night, when Earth and Mars draw especially close in their orbits. Watching the planets can be like following characters in a play that unfolds across the nights and seasons. Venus might grace the evening for months, then vanish in the sun's glare, only to reappear before dawn as the morning star, delighting early risers. Jupiter might spend the winter dominating the midnight hours, then shift to the west by summer's end, setting soon after twilight. Mars might appear as a timid, distant red dot 1 year, and 2 years later blaze bright and close, wearing its characteristic ginger hue proudly. These changes are subtle from night to night, yet dramatic over longer stretches, providing a slow celestial choreography that anyone can witness with a bit of patience. It's a dance that repeats through time, comforting in its familiarity and fascinating in its pattern. Even with their wandering, the planets follow a very orderly path. They all travel along nearly the same invisible track in the sky, the ecliptic, which is the plane of our solar system projected onto the heavens. Along this path lie the 12 traditional constellations of the zodiac. Thus, one will notice that planets are always found among the zodiac constellations, never straying into the far northern or southern reaches of the sky. This band of sky is like a broad highway, and the planets move within its lanes, each at its own speed. There is something reassuring about this consistency. We know where to look for them, always along the route the sun travels during the day. It is as though the planets are following a guide, staying true to a shared road across the firmament. On occasion, the planets will appear to meet or pass each other in the night. These events are called conjunctions, when two wandering lights draw very close together from our perspective. A bright conjunction of Venus and Jupiter, for instance, can be a breathtaking sight. Two brilliant jewels, almost touching in the twilight sky. Ancient astronomers took note of such meetings, as well as gatherings of planets with the crescent moon, seeing in them special significance, or omens. To the modern sky gazer, they are simply beautiful, rare alignments, like seeing old friends greet one another with a cosmic handshake. One of the more mysterious behaviors of the planets, which puzzled early observers greatly, is something we now call retrograde motion. Usually, planets drift eastward against the star background. From night to night, they shift slightly toward the east. But at certain times, a planet like Mars or Jupiter will slow, stop, and then move westward for a while before resuming its normal eastward course. To ancient eyes, it was as if the planet changed its mind and backtracked. Imagine tracing Mars night after night. Most of the time it edges forward among the stars, but during retrograde it seems to slide backward, looping a little loop in the sky. We now understand that this is an illusion created by the motion of Earth overtaking an outer planet, or being overtaken by an inner one, as we all orbit the sun. It's like when you pass a slower car on the highway. Momentarily, that car appears to drift backward relative to distant scenery. In the vast, quiet highway of the solar system, Earth occasionally passes Mars or Jupiter, and for a couple of months, from our moving vantage, those planets seem to reverse course. Far from being a chaotic quirk, retrograde motion is a graceful consequence of orbital dance, a reminder of the true heliocentric clockwork that our ancestors eventually came to understand. From the standpoint of a stargazer lying on a blanket in a field, these wanderers add a sense of friendly familiarity to the night. Night after night, you might grow fond of a bright point on the horizon, knowing it to be Venus, bidding the day farewell, or smile at the steady glow of Jupiter, climbing as the evening progresses. Perhaps you trace the slow migration of Saturn through the stars of Aquarius or Capricornus, noticing how over the months it shifts position gently. These planets become like companions, on your evening walks or moments of contemplation. They were the clock and calendar of our ancestors, markers of seasons and cycles. They also fueled stories. The fiery redness of Mars was associated with a god of war, the golden steadiness of Saturn with harvest celebrations, Jupiter's kingly brightness with the ruler of the gods. Yet here, in the quiet context of our modern appreciation, we need not attach omens or astrological weight to their presence. We can simply enjoy them as ancient lights that have always been there and continue to be there, moving in their predestined patterns, almost comforting in their predictability. Each planet also has its own character as seen from Earth. Venus, wrapped in reflective clouds, dazzles us and even casts faint shadows on moonless nights when at her brightest. Mars, when near, shows off that distinct ruddy tint, evoking the iron-rich deserts that cover its surface. Jupiter, even through a small telescope, reveals cloud bands and dancing moons. But without any aid, its very brightness and heft in the sky announce it as the giant of our cosmic neighborhood. Saturn's subtle glow belies the stunning rings that a telescope would uncover. To the unaided eye, it remains a demure dot, almost modest about its splendor. Mercury, the fleet-footed messenger, usually hides in the sun's glare, but when caught, its quick appearances at dusk or dawn always feel like special occasions, a little surprise gift from the cosmos. As we track these planets and learn their rhythms, we come to sense the solar system as a living, moving family. The Earth we stand on is one among them, and our motion is part of the grand pattern. The planets are not just lights in the sky, but worlds, sisters of Earth, reflecting the sun's light and sharing the sun's warmth. Realizing this can bring a quiet profundity to watching them. They are our celestial neighbors, visible across tens or hundreds of millions of miles, yet influencing our imaginations and, in subtle ways, even our environment. But mostly, they influence our sense of perspective and wonder. In a clear evening, identifying a planet among the stars can feel like recognizing a familiar face in a crowd. There is comfort in that recognition and a spark of connection across space. These wandering lights have been with humanity since the very beginning, guiding some, inspiring others, always present in our sky's story. Even now, when much has been discovered about their true natures, seeing them still evokes a calm excitement. They remind us that the night is not static. It is alive with planets in motion, each contributing to the silent cosmic dance above. Our journey through the night thus far has brought us the steady moon, the quietly turning sky, and these loyal planets. Yet there are other visitors too, ones less regular and more fleeting, arriving unexpectedly or cyclically after long absences. Occasionally, the night is graced by the apparition of a comet, trailing a wispy veil, or by a sudden rain of shooting stars as Earth travels through the dusty remnants of an ancient comet's tail. These are wanderers of a different sort, not constant companions like the planets, but brief guests that nonetheless leave lasting impressions. With the familiar planets keeping watch, we now turn our attention to these more transient phenomena, the comets and meteors, that add moments of surprise and splendor to the night. Far out on the edge of the solar system, a ball of ice and dust travels in solitude, orbiting the sun on a path that might take decades or millennia to complete. Every so often, one of these ancient visitors finds its way into the inner solar system, and we on Earth are treated to one of the most serene spectacles in the sky, a comet. To the naked eye, a comet appears as a softly glowing smudge among the stars, often with a delicate tail stretching away from the sun. Unlike the pinpoints of planets or stars, its light is diffused, as if a gauze-like cloud were drifting across space. On a dark night, away from city lights, spotting a comet can feel like discovering a secret. You may notice a faint, fuzzy star where none was before, and with binoculars you discern the telltale tail, a gentle fan or streak of light trailing behind a brighter core. The comet moves slowly, night after night, against the starry background, reassuringly steady in its progression, a visitor in no hurry. Comets have long captured human imagination. In ancient times, their sudden appearance, sometimes with tails spanning a large portion of the sky, was met with astonishment or dread. But in reality, these are peaceful travelers, cosmic snowballs releasing vapor and dust as they warm near the sun. The tail that we see glowing is formed by sunlight catching those tiny particles and gases, a glowing contrail in the vacuum of space. There is no turbulence or roar accompanying a comet's journey, only the silent grace of its motion. If you could watch over hours, you would see it inch among the stars, a journey visible only through patient observation. Often, a comet will grow in brightness over days or weeks, then wane as it recedes back into the depths, as if the sun's brief embrace brought it to life, and once released, it returns to slumber. Each comet is unique. Some have long, straight tails. Others display broad, fan-like tails, or even multiple streamers. The colors captured in photographs might show bluish or golden tints, but to our eyes, a comet usually appears pale white or faintly greenish. Regardless of hue, the effect is gentle, a soft brushstroke of light. In a way, comets are like the slow-moving ballet dancers of the sky, appearing unexpectedly, dancing for a while, then quietly exiting the stage, not to return for many years. Halley's Comet, perhaps the most famous of all, graces Earth's skies about every 76 years, linking generations who witness its return. Others, like Comet Hale-Bopp in the late 1990s, put on a spectacular show with two bright tails and then journeyed onward, not to come back for thousands of years. Some comets are one-time visitors on trajectories that will never bring them back once they swing past the sun. Knowing this can lend a poignant beauty to their appearance. For that one moment in time, we share the same space with a traveler from the farthest reaches of our solar system. As a comet slowly fades and the night sky returns to normal, another kind of celestial spectacle might take its turn, one even quieter and more fleeting. On certain nights of the year, if you find yourself under a clear, dark sky and gaze upward long enough, you may see a streak of light flash across the heavens. This is a meteor, often called a shooting star, though it is not a star at all. It is usually a tiny grain of cosmic dust or a pebble entering Earth's atmosphere at incredible speed, glowing brightly for a brief moment as it burns up. Most meteors last barely more than a heartbeat. They scratch a short, bright line and then vanish, leaving you to wonder if you truly saw one or just imagined a glint. But the experience is real, and it can feel magical, nature's own subtle fireworks. On an ordinary night, you might catch a few meteors if you're patient and scan the sky. However, at certain times each year, Earth passes through streams of debris left behind by comets long ago. When this happens, we experience meteor showers, periods when these shooting stars become more frequent, gracing the sky like gentle rain. The Perseids in August, for example, are among the most beloved meteor showers. On a warm summer night, one can lie back on the grass or a reclining chair, gaze at the broad expanse of the sky, and perhaps see dozens of meteors streak by over the course of a few hours. They peak after midnight, when our part of Earth faces the oncoming stream of particles head-on. Each meteor zips by silently. Occasionally, a slightly larger one might leave a glowing trail that lingers for a couple of seconds, slowly fading away. There's no sound, no loud burst, just silent sparks in the sky. Watching a meteor shower is an exercise in patience and serenity. Minutes might pass with nothing, and then a flurry of 2 or 3 shooting stars might appear almost at once, zipping in different directions. No matter how many one has seen, each meteor elicits a tiny thrill, and often a spontaneous, whispered, "Ah," perhaps the only sound in an otherwise silent vigil. Traditionally, people say you can make a wish upon seeing a shooting star. Perhaps this came about because they are so ephemeral and surprising. Catching one feels like a gift, a momentary opening between our world and the heavens. During a good meteor shower, that sense of gift is multiplied, yet never does the sky feel loud or overwhelming. The meteors come as gentle reminders of the vast activity in space that goes on even when we don't see it. There are times when meteor showers have startled with intensity. Historical records tell of nights when meteors fell like rain. But those are rare, once-in-a-lifetime events. Most often, even the well-known showers like the Leonids or Geminids offer a more modest sprinkle of shooting stars, entirely satisfying in their subtlety. Often, the best conditions involve nothing more than a comfortable spot to lie down, a blanket of night above, and a willingness to watch and wait. Lying outdoors in the pre-dawn hours, bundled against the chill, eyes scanning the sky for these fine streaks of light, one cannot help but feel at peace. The steady background of crickets or a soft breeze might be the only terrestrial sound, as your eyes remain attentive for those silent travelers. Each meteor is a brief connection between Earth and the cosmos, a tiny piece of another world, giving its last light as it becomes part of our world. In that instant of crossing paths, we are reminded that Earth too is moving through space, ploughing through invisible dust left by comets that perhaps last visited when our ancestors were young. Comets and meteors are related in this cosmic story. As a comet travels near the sun, it sheds bits of itself, dust and small rocks, along its path. Over time, these bits form a diffuse, invisible stream trailing the comet's orbit. If Earth's orbit intersects that stream at the same time each year, we encounter those particles and they bloom as meteors in our atmosphere. Thus, meteor showers are like the ghostly echoes of comets, appearing on schedule long after the parent comet has moved on. It's a graceful arrangement. The comet puts on one display with its shimmering tail, and years or centuries later, its leftover dust paints fleeting streaks in Earth's sky. Both are beautiful in their own way, and both speak to the cycles and connections in our solar system. When you next see a shooting star, remember that it might be a tiny remnant of a comet's tail from ages past. And if you ever spot a comet, know that the very dust it leaves behind could be responsible for a future generation's quiet night of meteor watching. In this way, even these brief phenomena knit into the larger tapestry of celestial rhythms. As our planet continues its journey around the sun, not only do we encounter these roaming messengers, But we also experience the grand turning of the seasons, marked by the sky itself. Beyond the transient flashes of meteors or the rare visits of comets, the regular progression of the sun, stars, and Earth's tilt creates a calendar in the sky. The changing constellations, the shifting length of daylight, and the rising and setting points of the sun throughout the year all compose a slow, steady metronome by which our ancestors told time. Having admired the ephemeral, we now turn to the enduring patterns overhead. The solstices, equinoxes, and the sky's soft metronome through the year, guiding the flow of the seasons. Throughout the year, the sky slowly changes its stage. The stars of winter evenings are not the same as those of summer, and the sun's path across the sky rises and falls with the seasons. These shifts happen gradually, almost imperceptibly from one day to the next, yet over months they become unmistakable. In ancient times, people watched these changes closely, for they were the only calendar needed. The heavens themselves kept time. With no ticking clocks, the progression of the sun and stars was a gentle metronome, and the year could be read in the dome of the sky as easily as in the unfolding of flowers or the turning of leaves. At the heart of this sky calendar are the solstices and equinoxes, the four corner markers of our planet's yearly journey. Consider the solstices first. In June and December, for those of us in the north, it is summer and winter. For those in the south, the opposite. The sun reaches the extremes of its height at noon, and the extremes of where it rises and sets along the horizon. Around the June solstice, the sun climbs highest in the sky at midday for the northern world, casting the smallest shadows and bathing the days in the most light. It rises far to the northeast and sets far to the northwest, taking a long, high arc through the sky. These are the longest days, when twilight lingers late into the evening and dawn comes early, a time of warmth and growth. In the far north, the sun barely sets at all, skimming the horizon in a midnight dusk. It's as if the sun is stretching its reach, gifting as much light as possible. Conversely, around the December solstice, the sun's arc is at its lowest and shortest for the northern hemisphere. It rises in the southeast and sets in the southwest, staying near the horizon throughout its brief journey across the sky. These are the short days, when the sun appears to hurry from dawn to dusk, and the night dominates. In some places far north, it might not rise above the horizon at all, resulting in a polar night that, while dark, is often calm and beautiful in its own way. For those farther south on the globe, the roles reverse. December brings summer's peak, and June the winter's quiet. Thus, the solstices are pivotal moments when the sun seems to pause in its north-south journey and then gently reverse course. In fact, the word solstice comes from Latin meaning sun stands still, reflecting how, for a few days, the change in the sun's noontime height, or its rising and setting points, is so slight that it appears to stand in place. Between these extremes lie the equinoxes, occurring around late March and late September. On an equinox, day and night are of nearly equal length all over the world. The sun rises exactly in the east and sets exactly in the west. There's a balance to these days, a kind of cosmic symmetry that people have celebrated and noted for millennia. The March, vernal, equinox heralds spring in the north, autumn in the south. It's a time when the days and nights match each other, and then the days overtake, growing longer and warmer. The September equinox welcomes autumn in the north, spring in the south, when the long days of summer give way and nights begin to encroach once more. Many cultures have festivals around these times, sensing the significance of these turning points. The equinox sky is special too. At sunset or sunrise, one can look due west or due east and see the sun setting or rising precisely along that cardinal direction, a guidepost of perfect alignment. Between the equinoxes and solstices, the changes in the sky are gradual but steady. Each day after the winter solstice, the sun climbs a little higher at noon. The days lengthen by minutes, and the sun's path shifts slightly northward. Shadows at midday shrink bit by bit. Early risers notice the dawn coming a tad earlier each week. Similarly, after the summer solstice, the sun's high point at noon sinks lower with each passing day, and daylight slowly recedes. It's as if the world breathes in and out, inhaling light towards midsummer, exhaling it towards midwinter. These shifts are subtle. A single day's difference might escape notice, but cumulative change over weeks is clear. By observing where the sun rises or sets along the horizon at different times of year, one can tell the season. For instance, you might recall that in summer, the evening sunlight came through the northwestern window of your home, whereas in winter, it streams through the southwestern one. The sun's changing position paints our surroundings with different light, golden, long rays in winter, almost overhead radiance in summer. Not only the sun, but the stars tell the seasons. Step out on a clear evening, and the canopy above offers seasonal constellations, as reliable as a calendar page. In the northern hemisphere, the great hunter Orion dominates the winter nights, his bright belt and shoulders gleaming on crisp, cold evenings. By summer, Orion has vanished below the horizon, and the summer triangle, a trio of stars high overhead, takes his place amid the warm, cricket-chirping darkness. In autumn, the great square of Pegasus and the story of Andromeda ride high, while spring brings Leo rising in the east, followed by the glittering orange of Arcturus. In the southern hemisphere, constellations like the Southern Cross shift position with the seasons, and the majestic sweep of the Milky Way arches differently overhead from summer to winter. For those who know the stars well, their arrival and departure are like the return of old friends at expected intervals. Long before mechanical clocks or modern calendars, humans looked to these celestial patterns to know when to plant, when to harvest, or when seasonal rains might come. The sky was a trusted timekeeper. Imagine an ancient stone circle or a temple aligned with the heavens. Many such structures exist, from Stonehenge in England to the temples of Karnak in Egypt, or the Sun Dagger site in the American Southwest, where on solstice dawn or equinox day, the sunlight will pierce a specific window or gap, illuminating a special stone or carving. These are testaments to our ancestors' attentiveness to the sky's calendar. In a world without electric light, the cycles of nature and sky were vividly apparent and significant. Celebrations often coincided with these celestial milestones: the return of the life-giving sun at winter solstice, the gratitude for abundance around the fall equinox, the hopefulness of spring's equinox when day and night find balance. There is comfort in the regularity of these cycles. Each year, no matter what has happened in our human world, the sun will reach its low point and then climb again. The dark, cold days will slowly brighten into spring. Conversely, the long, lazy evenings of summer will inevitably shorten, leading us back into the quiet of fall and winter. The sky's metronome never stops, but it ticks in a leisurely fashion, encouraging us to slow down and notice. One doesn't see a season change in a single moment. It unfolds gently. One morning you notice a chill that wasn't there before, or a particular star, now visible at dusk, that had been absent. These are the subtle cues of the sky's clock. Even the moon plays a role in the natural calendar, though its cycle is monthly, overlaying the yearly solar cycle. The word month itself comes from moon, and many calendars of old were lunisolar, balancing the moon's cycles with the sun's to keep in step with the seasons. Certain full moons acquired names that corresponded to seasonal markers: harvest moon, hunter's moon, flower moon, reflecting the activities or natural phenomena typical of that time of year. These names show how closely tied human life was, and in many ways still is, to the cadence of the cosmos. Standing outside on an equinox twilight, with day and night in temporary balance, one might feel a sense of equilibrium. Likewise, at a solstice sunrise, watching the sun peek over its most extreme horizon point, one senses the turning of the great wheel of the year. There is a profound yet quiet joy in knowing you are part of this grand cycle, that every living thing is carried along in the same progression of spring, summer, autumn, winter, and back again. The sky choreographs this dance without words, without effort, simply by the geometry of Earth's tilt and orbit. As we attune ourselves to these celestial rhythms, we gain not only a tool for timekeeping, but also a feeling of connectedness to something vast and enduring. The stars above that signal the seasons are the same stars that guided our ancestors and will guide generations after us. The sun's warmth and retreat define the storyline of every year, a story that we all live through collectively. It's a comforting thought that, as personal and unpredictable as our lives can be, the broad strokes of time, the return of spring, the peak of summer, the autumn winding down, the deep rest of winter, continue unchanged, shared by all living creatures under the sun. As evening falls on one of these seasonal milestones, you might find yourself reflecting on the passage of time with a kind of peace. The sky has been our teacher in patience and cyclic renewal. And as the stars begin to appear one by one, another aspect of the sky's guidance becomes clear. Beyond telling us when we are, the sky can also tell us where we are. For centuries, travelers and explorers looked to the night sky, not for the date, but for direction. As constant as the seasons are, the guiding stars like Polaris, or constellations like the Southern Cross, helping orient those who roam beneath them. Now that we've followed the sky's calendar through the year, we turn to these navigational stars, our silent compass in the darkness, to see how the sky helps us find our way. Night after night, a particular star in the northern sky holds almost still. While all the other stars slowly wheel around it, this star remains a nearly fixed point. That star is Polaris, the North Star. For anyone in the northern hemisphere, finding Polaris means finding north, high above the horizon for those far north, and lower down for those farther south. Polaris has guided travelers for centuries. Imagine a traveler in an open field, or a sailor on a dark sea, turning their eyes upward to seek orientation. The Big Dipper's pointer stars, the two outer stars of its bowl, draw a line that points faithfully to Polaris. Once Polaris is found, you know that direction is north, and from that you can discern east to your right when facing Polaris, west to your left, and south directly behind you. In a world before GPS or even magnetic compasses, this simple truth was a beacon of safety and assurance. So long as Polaris could be seen, one was never truly lost. Polaris is not the brightest star. Many are surprised to find it rather modest in brightness. But its steadfast position more than makes up for its relative faintness. On a clear night, away from city lights, Polaris is easy to spot, a humble jewel in the north, nestled at the end of the Little Dipper's handle. Around it, the rest of the northern sky appears to rotate, making a grand circle every 24 hours. Time-lapse photographs show concentric rings of star trails, with Polaris at the center, a still hub in the cosmic wheel. This happens because Polaris lies nearly at the north celestial pole, the point in the sky directly above Earth's north axis. As our planet turns, that pivot point stays put in the sky, and so does Polaris. Ancient navigators might not have understood the physics, but they understood the reliability. Polaris was the star that stayed put. To sailors and caravan travelers alike, its presence meant orientation and reassurance. Just by raising a hand to Polaris, they could gauge their latitude as well. The height of Polaris above the horizon roughly equals the observer's latitude on Earth, a fact that allowed skilled navigators to estimate how far north or south they were. In the southern hemisphere, there is no bright single star marking the celestial pole. The south sky's pivot is in a dim star field, making finding due south a bit more of a clever task. But the heavens provide a beautiful pointer: the Southern Cross. This small but striking constellation, Crux, has long been the key for navigators below the equator. The Southern Cross's 4 main stars form a compact, kite-like cross that is easy to pick out in the southern night. By drawing an imaginary line through its long axis, from the top of the cross down through the bottom, and extending it about 4.5 times its length, you arrive at a point in the sky near the south celestial pole. Dropping straight down from there to the horizon, you find south. Many a traveller in the vast Australian outback, or a sailor on the southern seas, has relied on this method. The Southern Cross itself, apart from its practical use, is steeped in culture and legend, featured on flags, embedded in indigenous lore, and serving as a nightly companion that both guides and inspires. Even away from the poles, the stars offer a compass to those who know how to read them. All stars, whether in the north or south, rise generally in the east and set in the west, except those near the celestial poles, which circle around without setting. This simple fact means that if you watch the movement of the stars for a short while, you can determine direction. In the early evening, for example, noticing a bright star rising ahead of you signals that you're facing roughly east. If you see a star sinking towards the horizon, you're looking roughly west. At dawn, the first light of the sun will always appear in the east. At dusk, the afterglow always lingers in the west. These are basic truths we intuit, but often overlook. Travellers in ancient times were highly attuned to them. Polynesian navigators, sailing over open ocean with no land in sight, memorized the rising and setting points of dozens of stars. Each star would rise at a particular bearing on the horizon and set on the opposite side, effectively giving them a celestial compass. If one guiding star set, they knew another would rise at the same bearing later in the night, ensuring continuous orientation. There is something profoundly comforting about orienting oneself with the stars. To lie beneath a clear sky and locate Polaris, or the Southern Cross, and from that simple act regain your sense of direction, can ease the disquiet of feeling adrift. Even when we are not literally on a journey, seeing these guiding stars can provide a symbolic sense of direction, a reminder of constancy in a world that sometimes feels in flux. The night sky, often associated with mystery or even disorientation, in fact holds the keys to finding our way. These special stars and constellations are like friends in the darkness. They might not be the brightest or flashiest, but they are steadfast and true. Imagine a lone navigator centuries ago, standing on the deck of a gently creaking ship at night. The world around is a vast, dark ocean, the wind and waves the only sounds. Above, the stars blaze in their millions. He finds Polaris low over the horizon, or perhaps, if in southern waters, he finds the Southern Cross hanging in the sky. By these signs, he knows his course. Perhaps a slight correction to starboard to keep on track. In that moment, the sky isn't just a backdrop of beauty. It is an active participant in the voyage, a trusted guide. This interplay between human and star can feel almost intimate. No words are spoken, yet guidance is given, received, and understood. Today, with our maps and digital tools, we rarely need to use the sky for navigation, and yet the stars still offer their guidance to anyone who seeks it. Try it yourself on the next clear night. Find the Big Dipper and use it to locate Polaris. Note how Polaris holds still as hours pass, while other stars wheel around it. Or, if you're in southern lands, find the Southern Cross and let it direct your gaze to the southern horizon. Notice how the arc of the Milky Way can stretch across the sky as a grand reference, and how certain star clusters or patterns return to the same place at the same hour, night after night. When you align yourself with the cosmos in this way, there comes a subtle sense of belonging and security. It's as if the sky says, "Fear not, I will guide you." The act of finding direction by the stars also connects us to all peoples who came before. We stand in a long line of explorers, nomads, and dreamers who looked up at essentially the same sky. Though the stars shift over millennia, and our North Star changes over vast periods of time, the pace of that change is slow. Polaris continues to hold north now, as it did for Viking longships 1,000 years ago. The Southern Cross points toward the pole now, as it did for the first Austronesian sailors who paddled between Pacific islands. In learning these navigational stars, we inherit an ancient skill. It costs nothing, and it works without fail, cloudless night after cloudless night. So tonight, if the skies are clear, perhaps take a moment to seek these celestial guides. Find a safe, dark spot. Let your eyes adjust, and the multitude of stars emerge. If you're in the north, track down the Big Dipper and follow its pointers to Polaris, gleaming quietly. Think of all the eyes that have found that star in ages past to steer them home. If you're in the south, locate the striking slant of the Southern Cross and appreciate how its form has been a compass for so many before you. Feel the earth turning under you as the stars ever so slowly shift. Breathe in the night air and sense that even as you stand still, you are part of a great journey, Earth's journey around its axis and around the sun, with stars as reference points. In the silence, these stars and constellations whisper that no matter how far you wander, there are always guideposts above. They remind us that orientation is both external and internal. With a bit of knowledge and trust, we carry our sense of direction within us, written in the stars overhead. And in the comforting darkness, guided by these ancient lights, we feel the quiet reassurance that our journey is far from over. The night is vast and full of wonder. Beyond the horizons we have touched, still lie innumerable treasures of the cosmos, softly beckoning us onward into the next chapter of exploration. In the stillness of the cosmic night, far from the bustle of bright galaxies and blazing stars, we drift into a realm of quiet potential. Here in the vast and velvety darkness, Immense clouds of gas and dust float like ghostly mist. These are the nebulae, the cradles of creation, silent nurseries where new stars are gently waiting to be born. From a distance, a nebula appears as a faint luminous patch, perhaps a soft glow against the black of space. But up close, it is mostly darkness and cold calm. Inside these immense clouds, the temperature is incredibly low, just a few degrees above absolute zero. Nothing moves quickly here. The gas atoms and tiny dust grains drift lazily, barely colliding, in an almost timeless suspension. A faint starlight from the outside may filter in, but deep inside the nebula, it is nearly lightless and still. In this cold gloom, gravity works ever so patiently. Over many millions of years, it gently pulls the gas and dust inward, tugging on even the smallest particles. At first, the changes are imperceptible. A slightly denser patch of cloud begins to draw in more material, becoming denser still, like a ghostly shape forming in a fog. Slowly, silently, the cloud's delicate balance tips. Gravity's embrace tightens around clumps of matter that were once spread thin. One by one, these clumps gather mass, growing heavier and contracting further, all in profound silence. From the outside, the nebula still looks tranquil and unchanged. But within, invisible seeds of new stars are taking shape. From the outside, a nebula might simply appear as a faint patch of light, but within it, countless stars can be in the making. For instance, the Orion Nebula, which to the naked eye is a hazy spot in the Sword of Orion, is in reality a bustling stellar nursery. Through telescopes, it blooms into a glowing cloud of colour, sculpted by the radiation of newborn stars inside. Similarly, in the Eagle Nebula lie the towering pillars of creation, colossal columns of gas and dust where new stars quietly gestate in their shrouded cocoons, their dark outlines gently backlit by nearby starlight. As each clump collapses further, it grows warmer at the centre. What was once just a cold spot in a cold cloud becomes a dense, hot kernel wrapped in layers of gas and dust. This embryonic star, a protostar, is not yet shining like the stars we see in the night sky. Its light is still feeble, trapped inside the thick cocoon of dust and gas. Only heat escapes, in gentle infrared glows that ripple through the darkness. To human eyes, it would still appear dark, but in truth, a quiet fire is beginning to kindle deep within. Gravity continues its patient work. The protostar's mass grows as more and more material falls inward. Infalling gas begins to spiral, drawn into a slow whirl around the centre. A broad disk of gas and dust forms, encircling the nascent star like a subtle halo. This disk is calm in appearance, but hides motion within. Particles orbiting, occasionally colliding softly, guided by the gentle pull of gravity. Within this circling veil, the star-to-be continues to compress and heat up, step by unhurried step. Over tens of thousands of years, the core of the protostar becomes denser and hotter. At first, it is still not enough to produce real starlight, but the temperature climbs steadily. Imagine an immense sphere of gas, millions of times the mass of Earth, all its weight pressing inward towards the centre. Slowly, inexorably, the pressure in that hidden core builds until something profound is on the verge of happening. The conditions necessary for a star's true birth are nearly met. In these cradles of creation, time flows in epochs rather than seconds. No sudden spark illuminates the cloud. Instead, a gradual turning point is reached. At last, when the central temperature climbs to millions of degrees, a quiet threshold is crossed. In that moment, deep inside the protostar's core, hydrogen nuclei begin to fuse into helium. A new light is born, softly at first, but growing. The furnace ignites, and a star's life truly begins, shining from within the cocoon that once hid it. Over time, the newborn star's radiance and gentle stellar winds push away the remaining veil of dust, unveiling the once hidden star to the cosmos. The dark nebula that was a cradle begins to glow softly, illuminated by the cluster of newborn stars emerging from within. What was once invisible now quietly shines, a new light among the ancient stars of the galaxy. It is the beginning of a long journey for this star, destined to burn quietly for millions upon millions of years. Deep inside the newborn star, an extraordinary fire is burning. In the star's core, countless hydrogen atoms are pressed so tightly together that they merge, transforming into helium. This process, called nuclear fusion, releases tremendous energy. But here it is released in a controlled and steady way. It is not an explosion, but a gentle, continuous burn, more akin to the quiet glow of embers than a roaring flame. The new star's heart is aglow, and this inner light slowly travels outward, providing the energy that makes the star shine. From the star's core, the energy travels outward through many layers. Inside the dense interior, the light struggles to escape. A photon, born in the core, may zigzag for thousands of years, bouncing between particles in the star's deep interior, taking a long, random walk before finally reaching the surface. This means the energy that eventually shines from the star has been on a slow journey, diffusing outward with great patience. When at last it reaches the star's outer layers, it radiates into space as the gentle starlight we see. Crucially, the star maintains a delicate balance during all this. Gravity, which once pulled the gas inward to form the star, continues to press inward on every bit of the star's mass. But now the core's fusion fire pushes back. The tremendous heat generated at the center creates pressure that tries to expand the star outward. In a young star that has just ignited, these two forces find an equilibrium. The inward pull and outward push counteract each other, and the star settles into a stable shape and size. This balance is like a peaceful, cosmic handshake between gravity and pressure. If the core burns a little too hot, the star's outer layers expand slightly, which in turn cools the core and slows the fusion reaction. If the core cools and fusion slows too much, gravity causes the star to contract a bit, which heats the core and increases fusion again. In this way, the star self-regulates, ensuring that it neither collapses nor explodes. Instead, it shines with a steady glow, its brilliance constant and calm over incredibly long spans of time. For most of its life, a star's light barely flickers. Unlike a candle flame dancing in the wind, a star's brightness holds steady through the ages. Our own sun, for instance, has illuminated Earth with remarkably consistent warmth for billions of years. Each day, the sunlight that reaches us has almost the same gentle intensity as the day before, a fact that has allowed life on our planet to flourish under a dependable star. Such stability is the norm for stars in their prime. Even so, stars are not entirely unchanging. Our sun, for example, follows a gentle 11-year cycle that causes dark blemishes called sunspots to appear and fade on its surface. Occasionally, it will send out flares of energetic particles. Yet these fluctuations barely dent the sun's overall brightness or steadiness. They are minor stirrings on an otherwise constant backdrop, a reminder that a star is a dynamic sphere of plasma, but one that keeps a near-perfect balance. Such stability is the norm for stars in their prime. They are enduring beacons in the darkness, burning their fuel slowly and evenly. In the quiet cosmos, this steady radiance is a reassuring constant amid change. On a clear night, as we admire the steady glow of the stars, they may all appear as white points at first glance. But if you observe carefully, you can discern a subtle rainbow of colours. Some stars twinkle with a faint icy blue light, while others shine with a warm golden or even orange-red hue. This diversity of starlight colours is not just beautiful to behold. It carries quiet secrets about the stars themselves. The colour of a star is a gentle clue to its temperature, a fact that astronomers have learned to read like a cosmic thermometer. Imagine heating a piece of metal in a fire. When it's only moderately hot, it glows a dull red, and as it gets hotter, it turns orange, then white, and eventually bluish at extremely high temperatures. Stars behave in a similar way. A star with a cooler surface, though still thousands of degrees, will appear reddish or orange, like a cozy ember in space. A star much hotter may shine white or blue-white, its fierce heat giving it a piercing sapphire tint. In between, there are stars like our Sun, glowing a gentle yellow-white, indicative of their moderate warmth. Thus, a star's hue is a direct reflection of how hot its surface is. Red for the cooler stars, blue for the hottest, and shades of yellow and white in between. If you gaze up on a clear night away from city lights, you might notice this colour spectrum with your own eyes. For instance, the star Betelgeuse, sitting in the shoulder of Orion, has a subtle orange-red sparkle, betraying its relatively cooler temperature. Nearby in the same constellation, Rigel gleams a bluish-white, a sign that it is far hotter. These colours are not vivid like neon lights, but gentle tints, noticeable if one looks for them, and they hint at the astonishing thermal differences among those distant suns. Sometimes, two stars of contrasting colours can be found together. Through a telescope, one might see a binary star pair, where one star shines blue-white and its companion glows golden-orange. Their combined light is a lovely sight, each colour making the other stand out more clearly, a silent stellar duet painted in different hues. Across the sky, each star quietly announces its heat with the colour of its glow. But colour is only one part of the story. Starlight holds even more information when we spread it out into a spectrum, much like unfurling a secret letter. If you pass a star's light through a prism or a special instrument, it separates into a soft band of rainbow colours. And within that rainbow, one can see delicate dark lines crossing certain hues. These faint lines are the star's whispering signatures of elements. Each chemical element in the star's outer layers absorbs a specific colour of light, leaving a tiny gap or line in the spectrum. By examining these patterns, a technique known as spectroscopy, astronomers can tell what a star is made of, even from light years away. It's remarkable to think that simply by analysing the faint light from a star, we can discern its composition. For example, the element helium was first discovered not on Earth, but in the Sun's spectrum. Long before we found helium in laboratories, astronomers noticed an unusual set of lines in sunlight, a silent clue that a new element existed in the Sun's atmosphere. They named it helium, after Helios, the Greek sun god. In this way, the light of the sun quietly revealed something brand new to science. Beyond composition, a star's spectrum can also tell us about its motion and other properties, though in subtle ways. If the star is moving toward or away from us, its spectrum shifts slightly, a phenomenon known as the Doppler shift, causing those spectral lines to move a bit toward blue or red. This too is a quiet message carried in starlight. It can let astronomers discern if a star, or perhaps something orbiting it, is coming closer or drifting farther. Even the speed of a star's rotation leaves an imprint, ever so slight, by broadening the spectral lines. All these details are encoded in the delicate light that reaches our eyes after traveling across space. To the casual stargazer, a star is a point of light, steady and enchanting. Yet hidden in that glow is a wealth of information, if one has the patience to listen with the right tools. A star's colour and its spectrum are like a gentle voice from across the void, telling the story of the star's nature. With nothing more than the peaceful light that falls to Earth, we learn of a star's heat, its ingredients, and even its subtle movements. It is as if the star, in shining, is speaking, softly and constantly, allowing us a glimpse into its distant world through the language of light. And when stars are born, they are rarely born alone. The vast nebulae that collapse to form stars typically give rise to not one, but dozens, or even hundreds of new stars in the same cosmic nursery. In those early times, these sibling stars cluster together, illuminating their natal cloud from within. Imagine a small region of space where countless infant suns sparkle in close proximity, like a sprinkling of jewels on black velvet. This is a star cluster, a family of stars born side by side, sharing the same age and origin. One famous example of such a family is the Pleiades, often called the Seven Sisters, a cluster of young stars that shimmer softly in the night sky. Through a telescope, or even binoculars, the Pleiades reveal a tight grouping of bluish stars, all formed from the same cloud about 100 million years ago, still travelling together through space. They are enveloped in a delicate haze of leftover dust, faintly illuminated by their starlight, a remnant of the nursery that birthed them. Clusters like this show us a snapshot of siblings in the early chapters of their lives, gathered close and shining as one picturesque group. If one could stand on a planet within such a cluster, the night sky would be spectacular. Dozens of sister stars would burn fiercely overhead, many times brighter than the stars we see from Earth. Their collective glow might bathe the landscape in a gentle radiance, even at midnight. It would be a sky crowded with jewels, a celestial congregation that gradually, over millions of years, would thin out as each star wanders its own way. In these youthful clusters, the stars are bound together by their mutual gravity, but only loosely. As the years pass, millions, then billions of years, the bonds between the stars gradually weaken. Each star in the cluster feels not only the pull of its siblings, but also the subtle tug of the entire galaxy around them. The Milky Way's gravitational field, along with encounters with other stars and clouds, begins to perturb the cluster. Bit by bit, members drift away from the group. We can picture it like a family of children growing up and leaving home. At first they stay together, moving as one group around the galaxy. Over time, one star after another wanders off, pulled by gravitational interactions, or simply moving on its own path. The cluster, once a tight-knit gathering, slowly disperses. Stars that were born as companions become isolated travelers, each tracing its own route around the galactic center. The dispersal is slow and silent. There is no sudden breakup, just a gentle spreading over the millennia. A cluster that might have been a brilliant jewel box in the sky eventually fades into the general background of stars. After enough time passes, its members become so far apart that the cluster is no longer recognizable as a group to the casual observer. They blend into the vast stellar populations of the galaxy, their shared origin betrayed only by subtle clues like their similar age and chemical makeup. Yet some star clusters endure far longer. Our galaxy is host to globular clusters, densely packed, spherical gatherings of stars that have remained together for billions of years. These clusters are not comprised of young siblings, but rather ancient stars, bound tightly by gravity in a great, glowing ball. In a globular cluster, hundreds of thousands of old stars crowd together, their light merging into a soft collective glow in the night sky. Unlike open clusters that disperse after a short time, globular clusters have survived nearly as long as the galaxy itself. Cosmic cities of stars that have scarcely changed for eons. They remind us that under certain conditions, star families can remain united on timescales that span almost the entire history of the universe. Our own sun is believed to have been born in such a cluster of siblings. Over 4.5 billion years, that original family of stars has long since scattered. Some of the sun's brothers and sisters may still roam the Milky Way, indistinguishable from other stars, except to the keen eye of analysis. Astronomers search for those lost siblings by looking for stars with the same fingerprint of elements and the same age as our sun, hoping to reunite our star's family on paper. It's a poignant thought that the sun's warm, steady light that nurtures our world once shone alongside many others in a packed nursery. Even today, we witness star clusters at various stages of this journey. Some clusters are very young, like glittering pockets of the galaxy where the stars are still crowding together. Others are middle-aged, with some members already straying. And some, like ancient open clusters, are barely held together at all, on the verge of dissolving entirely. Watching them is like watching time in a cosmic sense. We see the gradual coming of age of star families as they quietly disperse into the stellar sea. In the end, most stars that were born together will spend the majority of their lives apart. But for a while, in their youth, they share a special closeness. In those early eons, if one could visit such a region, multiple suns would fill the sky, each a bright beacon to the others. It must be a spectacular yet serene scene, a sky of sibling stars shining together before the slow goodbye. Over cosmic time, the family scatters, but the memory of their common origin remains written in the stars themselves. As the cluster disperses and each young star begins its solitary journey, within the space around each star, another story quietly unfolds. Around a young star that has just ignited, a thin disk of leftover gas and dust remains in orbit. This is the same disk we glimpsed earlier that formed as material spiraled into the protostar, and now it becomes the cradle of planets. In the quiet afterglow of the star's birth, the disk spreads out around the star like a broad, flat ring, opaque and shadowy close in, and more tenuous further out. Within this disk, countless tiny particles of dust are gently swirling, occasionally colliding as they orbit. Here, far from the turmoil of the star's core, a different kind of creation is underway, the gradual assembly of planets from the simplest of ingredients. It starts with specks of dust, microscopic grains that formed in the cool edges of the original nebula. These grains drift and bump into one another in the vast disk. In the vacuum of space, even a tiny grain moving relative to another can stick when they meet, especially if they are coated with ices or carbon-rich materials that make them a bit sticky. Static electricity might also help at these minute scales, causing dust motes to cling together like particles of flour gathering into clumps. Slowly, over years and decades, these grains accumulate into larger and larger pieces, from dust motes to sand grains, from sand to pebbles, and from pebbles to rocks. As time marches on, those rocks continue to meet and merge. In the gentle cauldron of the protoplanetary disk, collisions are not like the sudden, explosive impacts we might imagine. Many are slow, gradual encounters in the sparse gas and dust. A pebble here, a boulder there. When they collide at low speeds, they tend to stick, bound by mutual gravity and the materials binding them. Clumps grow into boulders, and boulders into mountain-sized chunks. Eventually, some conglomerates become large enough to be called planetesimals, essentially little planets, perhaps a kilometre or more across. These are the seeds from which full-grown planets will sprout. Once a few sizable planetesimals form, their gravity begins to influence the disk around them. They start to pull in nearby dust and smaller clumps, accelerating their growth. A kind of quiet competition ensues in the disk. The biggest bodies grow bigger by accreting more material, while smaller ones often get fragmented or swept aside. Over hundreds of thousands to millions of years, these dominant bodies clear their paths, gathering up material in their orbital neighborhood. We can imagine them carving subtle gaps in the disk as they sweep up dust, a process we've actually observed in some distant young star systems as dark rings in the glowing disk. In the inner regions of the disk, where the newborn star's heat is intense, only rocky material can withstand the temperature. Here, planetesimals tend to be made of metals and silicates, the stuff of rock. These may eventually form the rocky terrestrial planets, like Mercury, Venus, Earth, and Mars did in our solar system's youth. Thus, near the newborn star, any worlds that emerge are likely to be smaller, dense, and made mostly of rock and metal. Farther out, beyond a certain frosty boundary, temperatures are cold enough for ices to remain solid. In those outer reaches, planetesimals incorporate not just rock, but also plentiful ice, water ice, methane ice, ammonia ice. These icy, larger cores can grow massive quickly and start to attract the surrounding gas itself. They become the cores of future gas giants. In time, they accumulate huge atmospheres of hydrogen and helium from the disk, swelling into giant planets like Jupiter and Saturn. Thus, a young planetary system begins to take shape. A newborn star finds itself orbited by a retinue of growing worlds, some small and solid, some immense and gaseous, each coalescing in its own zone of the disk. They continue to sweep up remaining debris. Occasionally, two large protoplanets might collide, merging into a single bigger world, or sometimes shattering each other and starting the process anew with the pieces. One such titanic impact likely formed Earth's moon long ago. A wandering protoplanet the size of Mars is thought to have struck the early Earth, blasting out debris that coalesced into our moon. Even events so violent happen in eerie silence out in space, their grandeur known to us only through the traces they leave behind. Gradually, the disk becomes more and more depleted. The central star's radiation and stellar winds also help blow away the remaining gas and dust once the bulk of planet formation is done. After a few million to tens of millions of years, the once bright disk has thinned out and largely disappeared, leaving behind a newly minted solar system. Where there was once a continuous band of dust and gas, now planets circle in the quiet and near emptiness, separated by vast distances. They shine only by reflecting the light of their parent star, new worlds ready to embark on eons of evolution. In our own solar system, this grand assembly happened around 4.6 billion years ago. Tiny grains around the young sun eventually built up the Earth under our feet, and the other planets that accompany us. Remnants of that era still linger. The asteroids are leftover building blocks that never became part of a planet, and comets are icy crumbs from the outermost regions. They serve as subtle reminders of a time when everything here was just dust in a disk. It's a profound thought that everything we know, our planet's mountains, oceans, and even living creatures, emerged from those simple grains of cosmic dust. The quiet gathering in that ancient disk ultimately gave rise to all the complexity and beauty we now see on Earth. And in a very literal sense, we ourselves are made of that stardust, forged in ancient stars and gathered by gravity into this world. Through eons, cosmic dust became living beings, a transformation that connects us intimately to the universe that formed us. Now think of the countless stars in the night sky. Many of them, especially the younger ones, likely have their own disks and are forming their own planets as we speak, hidden in the darkness. These distant planetary forges are usually too far and too shrouded for us to see directly, but scientists have begun to detect hints of them. Sometimes it's the faint infrared glow of warm dust, or an image of a protoplanet carving a gap in a distant disk. And when those planets are fully formed and orbiting their star, we have ingenious methods to perceive their presence, even if we cannot yet gaze upon most of them directly. The stage is set for discovering these worlds beyond our solar system, listening to the whispers they send across space. For centuries, people wondered if there were other worlds circling the countless stars in the sky. But those planets were invisible to our eyes. Today, although we still cannot usually see these far-off planets directly, we have learned to detect them through the subtle effects they have on their parent stars. It's as if the planets speak in whispers, and with sensitive instruments, astronomers have become skilled at listening. At last, the existence of these faraway worlds is no longer mere speculation, but a reality we can detect through their faint effects on starlight. One of the most telling whispers from a distant planet is the faint dimming of its star's light as the planet passes in front of the star. Imagine watching a distant lighthouse and noticing that its light ever so slightly flickers at regular intervals, something small occasionally crossing in front of the beam. When a planet orbits its star and happens to line up just right from our viewpoint, it creates a tiny eclipse called a transit. The planet, though far too faint to see on its own, blocks a little bit of the star's light for a short time. If the star is being carefully monitored, this transit reveals itself as a slight dip in the star's brightness. This dimming is incredibly small, often less than 1% of the star's light, yet it carries profound meaning. In that brief reduction of starlight, we see the silhouette of a world. By measuring how much the light drops and for how long, scientists can infer the size of the planet and the length of its orbit. For instance, a big planet will block more light, and a planet in a close, fast orbit will cause frequent dips. These gentle light curves are like a star's heartbeat chart, with each tiny pulse indicating a planet passing by. Space telescopes have patiently watched hundreds of thousands of stars in this way, noticing the faint, regular flickers that betray the presence of orbiting planets. Through these vigilant observations, thousands of new worlds have been discovered. Another whisper of a planet's presence comes in the form of a star's subtle wobble. As a planet orbits a star, the star itself moves slightly in response to the planet's gravity. They actually both orbit around their common center of mass, so the star makes a small circle or ellipse. Seen from afar, we can't discern that tiny dance by watching the star's position directly, but we can detect it by looking at the star's light. As the star moves toward us, its light is minutely shifted toward the blue. As it moves away, the light shifts toward the red. This is the Doppler effect in action, the same principle we see with sound when a siren's pitch changes, now applied to light. By very carefully measuring these shifts in the star's spectrum, astronomers can tell that the star is moving back and forth, gently tugged by an unseen companion. To the telescope, this effect appears as a tiny rhythmic shift in the star's spectral lines, revealing the orbiting planet's presence. It's astounding how sensitive these measurements have become. In some cases, astronomers can detect a star wobbling at speeds of just a few meters per second, walking pace, due to the pull of a planet. From such data, the existence of planets is deduced without ever laying eyes on them. The amount of wobble reveals the planet's minimum mass. A more massive planet causes a bigger tug on the star. In this way, we have found giant Jupiter-like planets in tight orbits and smaller, Neptune-sized or Earth-sized planets farther out, all by reading the delicate movements of starlight. Each method, transits and wobbles, has its strengths. The transit method is best at finding planets that line up edge-on from our perspective, and it can even allow us to study those planets' atmospheres. When starlight filters through the thin rim of an atmosphere during transit, it leaves telltale spectral fingerprints. The wobble method can find planets in a variety of orientations, and is particularly good for massive planets, and it gives an estimate of their mass. Together, these techniques have opened a window into the diverse realm of exoplanets. We now know of planets circling stars all across the sky, from blisteringly hot gas giants hugging their stars to frozen worlds in distant orbits. Some stars have multiple planets, whole systems of worlds orbiting in resonance. The first planet discovered around a sun-like star was itself a surprise. A giant hot Jupiter circling extremely close to its sun, a configuration unlike anything in our solar system. Since then, we have found planets in all manner of orbits, challenging preconceived notions of how planetary systems form. Even tiny, cool stars can host rich planetary systems. One nearby star was found to have 7 Earth-sized worlds orbiting it, several in temperate zones where liquid water could potentially exist. On rare occasions, astronomers have even managed a more direct glimpse of exoplanets. By using special techniques to block a star's glare, they can sometimes capture faint infrared glints of large planets orbiting far from their stars. These direct images often appear as tiny dots next to a bright star in a photograph. But even such simple pictures are extraordinary. They are photons that have bounced off a planet many light years away, finally reaching our telescopes. Such feats require extraordinary precision and thus remain rare. Only a handful of exoplanets have been directly seen so far. For the most part, however, exoplanets remain elusive points of darkness, known to us only through their subtle influences on their stars. From the sum of these whispers, a remarkable understanding has emerged. Planets are abundant. Most stars seem to have at least one, and often several, worlds in orbit. Our galaxy is likely teeming with billions of planets, a realization that not long ago was pure speculation. Now, it is a quietly accepted truth, arrived at through patience and careful observation. Each star that dots the night sky may no longer be seen as a solitary beacon, but as a potential sun with its own family of planets. This realization makes the universe feel more intimate and alive. Not a sparse expanse, but one filled with countless unseen worlds, circling countless distant suns. Under the veil of distance, countless unseen landscapes circle suns of every kind. As we refine our techniques, we continue to uncover smaller and more Earth-like planets, edging closer to finding worlds that might resemble our own. And beyond merely detecting these distant planets, we yearn to know more about them. What are they like? Do they have atmospheres or oceans? In some fortunate cases, we can glean hints of an exoplanet's atmosphere by studying its starlight during a transit, noticing slight differences that reveal gases around the planet. These faint signatures are the next level of the whisper, not just that a planet is there, but something about what surrounds it. Such discoveries lead us naturally to the next quiet exploration, examining the gentle atmospheres of distant worlds for clues about their nature. A planet's atmosphere is like a delicate veil, a thin layer of gases wrapped around the world. Though it may be tenuous compared to the planet's bulk, an atmosphere can profoundly affect a planet's character, softening temperature extremes, nurturing weather, and colouring the sky. From afar, this fragile envelope is hard to detect, but under the right circumstances, it offers subtle clues about itself. Astronomers have begun to tease out these clues, extending our senses to sniff the air of planets light years away. One way we learn about an exoplanet's atmosphere is during a transit, when the planet passes in front of its star. In those moments, a tiny fraction of the star's light filters through the thin rim of the planet's atmosphere before reaching us. Most of the starlight goes straight by, but a small portion passes through that layer of gas, and molecules within it absorb certain colours of the light. By comparing the star's spectrum before, during, and after a transit, we can discern incredibly slight differences, the fingerprints of the planet's atmospheric gases. It's as if, for a brief moment, we witness a distant sunset through the planet's sky, allowing us to sample the air from afar. The changes in the spectrum are exceedingly subtle. Imagine trying to detect a faint tint in a beam of light that has travelled trillions of miles. Yet with painstaking observation and powerful new telescopes, scientists have done just that. They have identified signatures of water vapour, sodium, and other molecules in the atmospheres of giant exoplanets. For example, in some hot, bloated planets orbiting very close to their stars, we've detected sodium and potassium, evidence of exotic, cloud-free skies that let these elements imprint on the starlight. In others, we see signs of high clouds or hazes that mute certain expected signals, indicating atmospheres loaded with vapour or dust. Every atmospheric clue paints a faint portrait of a world's conditions. A detection of water vapour might suggest the possibility of clouds or even rain high up in that alien sky. Finding carbon dioxide or methane could hint at greenhouse conditions or even exotic chemistries at play. The presence of a thick haze might mean a world perpetually enshrouded in twilight glow, its surface hidden beneath. Even without a direct view, these spectral whispers let us imagine what it might be like on those distant worlds. Perhaps a dim orange sky with permanent clouds, or a clear atmosphere where one could see the star glaring in a coloured heaven. We can look to our own solar system for context. Earth's atmosphere, though just a thin blue film around the globe, is rich in oxygen and water vapour, telltale signs of the life and liquid water it harbours. Our neighbour Mars has only a tenuous atmosphere, primarily carbon dioxide, giving it a pinkish sky tinted by dust. Venus wears a dense shroud of carbon dioxide with clouds of acid, hiding its surface entirely and trapping heat in a runaway greenhouse. Then there's Titan, Saturn's mysterious moon, swathed in an orange haze of nitrogen and methane. Its thick air conceals a frigid landscape where methane rains might fill icy lakes. Each of these examples shows how an atmosphere can drastically shape a world's environment. Seen from light years away, those differences would announce themselves as distinct spectral signatures. Earth's spectrum would reveal the presence of oxygen and water vapor. Mars and Venus would show primarily carbon dioxide. Titan's haze would be marked by methane. With the newest generation of telescopes, such as those orbiting above Earth or the great observatories on high mountain peaks, we are at the threshold of studying smaller exoplanets' atmospheres, even some that are nearer to Earth in size. Already, these advanced observatories have made landmark achievements, detecting, for instance, the unmistakable signature of carbon dioxide in the atmosphere of a planet many light years away. Such measurements, once thought impossible, are now becoming reality, giving us our first detailed glimpses into the chemistry of alien skies. We hope to find the gentle indicators of habitability, perhaps a hint of water in a temperate planet's sky, or the presence of oxygen, which on Earth is replenished by life. So far, most atmospheric studies have been on big, hot planets, but each year brings us closer to glimpsing the air of a rocky Earth-sized world. It is a slow and careful endeavour, requiring the planet and star to align just right, and the instruments to be incredibly sensitive. But step by step, the once invisible atmospheres of far-off worlds are becoming knowable. Perhaps one day, we will even capture an image of an Earth-like planet circling another star. It would likely appear only as a tiny bluish dot in a telescope, but within that dot could be oceans and continents, clouds and sky. Seeing such a distant, pale blue dot would be a poignant sight, a reminder of our own world and a hint that another could be waiting with its own quiet landscapes and skies. That one speck of light would transform a star from an abstract pinprick into a real place, a new world that we can begin to imagine. There is a profound quiet magic in detecting an atmosphere across cosmic distances. From a mere pinprick of starlight, we extract the presence of alien skies. We begin to know whether a planet might have blue skies or orange hazes, scorching clouds of iron or gentle mists of water. Each discovery of an element or compound in an exoplanet's air is a whisper from that world, telling us a small part of its story. These whispers inspire us to wonder, could there be clouds and rains there? Oceans or lakes beneath that sky? Somewhere out there, perhaps a planet is shrouded in an atmosphere not unlike our own, quietly sustaining lakes or even life. The search for such places leads us onward. It guides us to consider the many forms that habitability might take, from familiar warm oceans to the most unassuming methane lakes and hidden subterranean seas. Our journey now turns to these quiet oceans of possibility. What makes a world habitable or alive? We often think of Earth-like conditions, mild warmth, liquid water, a cozy atmosphere. But as we discover more about our universe, we realize that habitability may come in many forms, some quite unlike our own planet. It is less a single narrow threshold and more a spectrum of possibilities, each with its own quiet niche for life. From scorching sunlight to eternal night, from water to other liquids, life might find footholds in surprising places. Take Titan, for example, the moon of Saturn we mentioned earlier. Titan is unimaginably cold by earthly standards, with a thick haze that dims the feeble sunlight reaching its surface. Yet, in that deep freeze, Titan has lakes and rivers, not of water, but of liquid methane and ethane. On Titan's frigid shores, gentle waves of methane lap against icy rocks. No human could survive there, but one can't help but wonder if some strange life form might, in theory, swim in those liquid methane lakes or metabolize with chemistry alien to our own. It's a radical notion of habitability, a world utterly unlike Earth, calm and cold, yet with its own cycle of rains and lakes, a sort of mirror to our water cycle, playing out in slow motion under an orange sky. Then consider the hidden oceans inside icy moons, like Jupiter's Europa or Saturn's Enceladus. On the surface, these moons are frozen solid, quiet, harsh, and airless. But beneath kilometers of ice, we have strong evidence that global oceans of liquid water exist, kept fluid by the warmth of the moon's interior. We have even observed hints of these buried seas. On Enceladus, for instance, geysers of water vapor erupt from cracks in the ice, revealing a liquid ocean below the frozen crust. In those lightless oceans, heated perhaps by underwater volcanoes or by tidal friction, there could be environments analogous to the deep sea vents on Earth, where life thrives without sunlight. Encased in ice, such oceans would be among the quietest seas in the universe, undisturbed by wind or weather, stable for billions of years, a potential cradle for life in the cosmic dark. If life can spark in such places, it might remain safely hidden under a protective ice blanket, quietly going about its existence while the rest of the universe passes by. In a sense, these hidden oceans are like cosmic wombs, insulated, stable, and sealed off, perhaps allowing life to quietly blossom inside. Even on planets somewhat like Earth, the range of possible habitats is broad. One world might be mostly ocean, with gentle waves rolling over a global sea, no continents at all. A water world where life could be entirely aquatic. Another might be drier, with life clinging around rare oasis lakes under a dim sun. Some could have thick, steamy atmospheres blanketing a wet, hot surface, where warm rain perpetually feeds vast swamps. Others might be cool and cloudless, with shallow seas stretching beneath pale skies. With each new exoplanet discovery, we expand our idea of what a livable world can be. On Earth, we've found hardy microbes in boiling hot springs, in frozen Antarctic lakes, in the crushing dark of the deepest ocean trenches. Life here has proven to be astonishingly adaptable, flourishing in conditions that would once have seemed utterly inhospitable. This teaches us that life elsewhere might not require a perfect Earth clone, merely a niche where basic needs can be met. Perhaps an alien ocean under thick ice, or a tranquil methane lake under a hazy sky, could host its own humble organisms. We haven't found such life yet, but knowing it's not impossible expands our hope. And so, when we gaze up at the stars, or study those distant planets, we keep an open mind. Maybe on some far-off world there is a calm ocean, whether of water or some other liquid, where simple creatures drift and swim. Maybe in a cavern beneath an alien surface, microbes cluster around warm rocks, living out their quiet cycles unseen. We imagine these scenarios not with certainty, but with wonder, aware that nature often surprises us. The silence of those distant seas does not imply emptiness. They could be like the quiet of a deep forest at night, full of life, just hushed and hidden. For now, these possibilities remain speculative. Our current technology can scarcely scratch the surface of such mysteries. Yet the mere possibility urges us onward, to send probes to the icy moons in our own solar system, with one such mission, Europa Clipper, on the way to study Europa's hidden ocean, to build telescopes that can analyze the atmospheres of far-off Earth-sized planets, and perhaps one day to send tiny emissaries to nearby stars. We are driven by the quiet thrill that we might find something alive out there, no matter how simple, thriving in some niche we once thought impossible. The universe suddenly feels more intimate knowing that the ingredients for life are spread everywhere, and that nature can assemble those ingredients in profoundly different ways to spark biology. As we continue this gentle exploration, we carry with us the hope that one day the silence will be broken by a whisper of confirmation, a faint signal, a subtle pattern, some quiet evidence that we are not alone. Until then, we dream of those serene, distant lakes, the shadowed oceans beneath alien ice, and the myriad other worlds softly circling their suns. Each is a quiet wonder in its own right, a testament to the creativity of nature, and each offers a reminder that even in the vast hush of space, life may quietly flourish in forms and places we've yet to imagine. Our journey through these wonders goes on, ever patient, ever hopeful, and ever in awe of the cosmos.